Greetings, Saber fans. It's your old pal Megtooth Sith. This is a video for installing this lightsaber. I go into depth and detail about stock connectors, 4-leg momentary switches, recharge port, battery, speaker, and the Proffieboard, including some of the Proffie programming. So this is a very detailed video. That's why it's so long. It's 3 hours and 12 minutes long. God bless anybody who sits through the whole thing. Megtooth Monday viewers already sat through these. This was shot on 4 Megtooth Mondays. I do live videos every Monday night at 8:30 p.m. when I'm available. And this video is a glue together from all those Megtooth Monday lives that we installed this saber on. The total video was about 6 hours long, but I've edited it down to about 3 hours and 12 minutes. In this video, I also include a little faux pas I made with the battery. I include the bad stuff and the good stuff. So when you guys get to the mistake I made with the battery, I left it in there. I did leave the bad stuff in there. Bad stuff happens to anybody that's installing lightsabers has made a mistake at some point, whether it's damaging a soundboard or messing around with live wires and shorting something out, or tripping a battery protection circuit. It's happened. It's happened to every installer. It's just, I'm going to include it. It's the truth. I don't edit the truth out. I left the truth in there. And, I appreciate everybody watching the video and subscribing to my channel. You want to get notifications from me, hit that notification bell and subscribe to my channel. And without further ado, let's roll the beautiful bean footage. At any rate, this saber was done by Gary Morris, and it's almost like a saber within a saber. And this is what we're going to be working on tonight. There. So now that I have the hilt broke down into its main components, you can see it's already got 2 switch 22s that were installed in there. I don't know who did that, whether it was Gary Morris or Ryan Ronan. The recharge port, the 2.1 millimeter recharge port, is already installed in there as well. And now I've just temporarily put the stock connector in there, and this is the V2 of the main stock connector. It's not the Eco connector. And of course the battery is going to go here, which I didn't get that out yet. Speaker here, and of course we're going to have to put neopixels in there to illuminate the chamber. And I don't know if I'm going to be able to illuminate the chamber from behind because the wire passages are kind of small. But at the very minimum, we'll get all the main stuff in tonight, and maybe I'll see if I can eke some neopixel wires in there along with my speaker wires. I might be able to fit it all in there. But I think the big thing we're going to do tonight is wire up one of these stock V2 connectors. A lot of people have a lot of questions on these, and I see a lot of questions on the Saber groups, and I kind of want to, oops, I guess I need to loosen the retention pin on there. I buy these, and I had to modify this one to fit inside this hilt because it's a little less than 1 inch. But I buy the stock hilt adapters already assembled from Saber Bay, but I also buy Saber Bay's holders in 1 inch and 7/8 and Saber Bay's diffusion because it's pretty simple. So once you get the stock connector soldered up, you just put it through the diffuser like that, and I'll show this on better video here in a minute. And then the diffuser and the connector just snap right into your hilt adapter like that, and then you just slide this into your hilt, and Bob's your auntie, and you're up and running with the stock connector. Now, yeah, this is the manual we need. So I know sometimes people get a little bit weirded out in Dimitri's manual, but as you can see here on this page of the manual, page 5 of 16, there's 4 ways you can wire these. You can wire it just as a blade adapter, but if you're going to do that, you might as well just buy the custom Saber Shop ones that don't have the neopixels on the connector. So I don't know why anybody would do V1. Now V2, you can do the blade and PCB LEDs in parallel, which basically means that the 16 neopixels on this will do the same as the first 16 neopixels on your blade. Then you can do them in series as V3, where you only have 1 data line, but you can program them in series, so you can program them as sub-blades. And you're going to have to add the additional 16 LEDs in your config. But then you have V4, which is blade, and then the LEDs that are on the connector are independent of one another, and you actually have two data lines running off of that. Now, I know that we've discussed this before, and that, you know, everybody wants me to do subblades. I don't do subblades because I don't trust the redundant data. I don't trust subblades. I still don't trust subblades. But maybe someday y'all will convince me to do subblades. But I run these in V4 independent, and that allows me to control the onboard LEDs. So the opening in this hilt is just less than 1 inch where that adapter needs to go. So I actually had to, you know, take some of this material off of there so that the adapter would fit down inside of this hilt like that. But what I'm going to do now is, now we know we're going to do V4, I'm going to go back to screen share, and I want to show y'all something that a lot of people miss. The important thing to notice on V4, so I buy these assembled, and they actually come with both resistors, which I'll show you on the camera here in a minute. It comes with R2 and R1, and as you can see in V4, there's only R2, so there's not a data line resistor on R1, so you have to remove the R1 resistor if you're going to run this in V4. But I'll show all that here in just a second. And since I'm using 22 gauge, I'm only going to use one positive, one negative, but I will have two data. So I won't be in the frame in the chat too much tonight because we got a lot of stuff going on. So in the manual, I told you we have, you know, this is R2, which we're going to use R2 because we're using independent data because we're wiring this in V4 configuration. But we need to get rid of this resistor, which is on R1. And I've got my handy dandy soldering iron already heated up. So what I'm going to do is I'm going to heat up both pads on this resistor, and I'm going to try and punt it. And it can be tough. But there, I got it off. And there it is. Now, I'm going to clean up these pads and make sure that they're not bridged still. I don't want to do that other resistor. So there you can see, let me get it where you guys can see it. I've removed R1. Now, what I want to do, let me clean off my soldering iron and bring in my solder, is I'm going to pre-tin the data line that we're going to use for our redundant data. So on these stock connectors, this line right here, this is D2. This is for independent onboard pixels. This is where we're going to have an independent data line coming off. So I'm pre-tinning that pad to receive our data. Now, I'm going to take my multimeter out, and I'm going to zoom out so you guys can see the multimeter and hopefully see what I'm doing. So stand by. Let me zoom out. Oop, that's zooming in. Let's zoom out. Oh, come on, camera. It's so hard doing this stuff upside down and live and backwards. All right, so it looks like we're all the way zoomed out there. So I've got my multimeter, and I'm going to bring my multimeter in. I'm hoping you guys are going to be able to see all this. Let me try to sneak my multimeter under the tripod there. This is going to be precarious because it's not really wanting to balance like that. And the first thing I'm going to do is I'm going to check continuity here where we've removed this resistor and make sure I don't have continuity. And I don't. So when I touch the probes, I get the tone, but when I touch these two pads that were where our resistor was, I do not get tone. Now the second thing I'm going to do is I'm going to touch that pad we just tinned, and let me change the settings on this because I want to measure that resistor and make sure that we're getting the proper resistance on the data. So you can see there we got, oh, I was showing it for a second. Oh, it's so hard to do this and make sure y'all can see it in frame. So I got 327 ohms there on this data line. So this is the data resistor for our independent data, and that is the pardon me, that's the independent data for these 16 onboard resistors, and by the way, 16 onboard neopixels. So there's 16 of them. So we've done all that, so we're solid there. Now, our main blade data is going to solder directly to the center pin, because on all these Neopixel adapters, whether it's TCSS, 7-pin or 11-pin or stocks, the center pin is your main blade data. The outsides are your positives, and the inner circle are your negatives. And that's basically how that works. So basically what I'm going to do on this adapter, get it back in frame, is we're gonna solder I use 26 gauge for my main data here on the main pin. We're gonna solder a brown wire. I'm using 30 gauge for my secondary data, which is going to control the onboard LEDs. We're going to put that on that pad that we just tinned, which is D2. And then I'm going to add one positive wire on one of these positive poles. It doesn't matter which one it is, as long as I put it there. And then I'm going to add our one negative wire on one of these poles. Now there's all kinds of stuff you can do with blade ID and blade detect, but I'm not using any of that on this Saber. So I'm just basically wiring this, as normal. So I think the first thing I'm going to do is I've got some wire here, and let me get the multimeter out of there, and then I'll get zoomed back in here so we can go to work, and hopefully you guys can see what we're doing. I'll try and make sure that we're in frame here. But I think the first thing I'm going to do is I'm going to off frame. Oh, there's my brown wire. I don't need that yet. I think what I'm going to do is I'm going to take my purple wire, which is 26 gauge, and I'm going to strip it. So basically I'm going to pre-tin my data wire. Y'all have seen me do this a million times, and I'm going to trim it to size because I just don't want a whole lot of wire sticking out. I try to trim it so it's about as long as the pad and not much longer. And then, now that I've got my wire pre-tinned, I'm going to come in here and I'm going to tin our center data pin, and then I'm going to bring the wire in here. I'm going to melt the solder, and bada bing. And I think I moved it right before it solidified. Dimitri uses, or Justin, whoever's putting these together, they're actually using silver solder, and I use leaded solder. I know some of you guys are going to be like, leaded solder? You're going to die from lead poisoning, but, I do use leaded solder. But now I'm going to I'm getting ready to do my positive wire. Now the positive wire is on the outside, and on the adapters where it sets in, you don't want anything messing with the positive too much. So you want to run the positive inboard. So you don't want to run it outboard. So, and when I mean inboard, I'm talking about inward. So I'm pre-tinning one of the positive pads there, bada bing. And now, I should have taped this down. Now I'm going to bring in our positive wire, melt that solder. I couldn't really see that joint. Let's try and do that a little bit better. Sorry, I'm zoomed in here, but there. So there is my positive. I could probably do a little bit better soldering there, but trying to keep it on screen and where you guys can see it is going to be about impossible. Trying to, all right. Looks like y'all can see it there. I'm going to try and come in with some solder here, and bada bing. Beautiful. So there's our positive. So now I'm going to do the same with our negative. Let me see here. Need some wires to strip the negatives. Put that positive where you guys can see my positive and data are on there. Bada bing. But, everybody was worried about, dual, resistors, because the Proffie has the onboard resistor. I believe it's 330 ohms for data line 1. But most modern NeoPixel blades, most of the blade installers are actually putting the resistors on the blades So then the fear was, well, how much resistance is too much resistance on a Neopixel blade? And, you know, for some guys that are used to N-hilts, the resistor on a Neopixel blade doesn't reduce the brightness or limit the power that's going to the Neopixels. It's basically like a filter. It flattens out the noise in the data line, as it were. I should have taped this thing down. This one's going to be tough. This is negative. So I'm probably going to get this positive out of the way a little bit. I'm going to pretend a negative pad here. And I think I'm going to go to this one right here. Pretending it was solder. Got the wire in my mouth. Alright, here we go. Now, and hopefully that'll immobilize it, and hopefully you guys can still see where we're working there. That'll make my life a lot easier now. So now I'm going to heat up the pad. Get that solder good and flowy. And then I'm going to bring in the wire. God, I hate this silver solder they use. Hang on a minute. I will cure it. I will cure it. Because I'm going to bring in, I'm going to contaminate Dimitri's silver with some lead. Dimitri hates lead solder. Anytime he sees somebody saying that they use lead solder, he gets all upset. And I'll let that cool. Bada bing, bada boom. Sweetness. Alright, now, the last wire we have to do is going to be our data 2, which was the pad we pretended at the very beginning. That one right there. So, should be a little bit easier. So I'm going to reach around here, giving the old reach around to the secondary data wire, and you guys can see my shaky hands. Oh, come on now. Something got me there. There we go. Woo! That was a good one. That was a good one. Alright, so we're out. Bada bing. This bitch is wired. There is the V4 all wired up. Now, I'm using 22 gauge wire for my positive and negative. I'm going to test those for continuity and make sure I didn't bridge nothing there, because there's a lot of solder on that negative, probably too much. I know that one looks good and my main data looks good. I just want to check and make sure there's no continuity between my negative and my main. And I'm looking at it magnified there, and I think I'm going to be good. But at any rate, that's it. So all these negatives on that inner circle, they have continuity between them. So if you bridge, you know, two of the pins that are side by side, you're okay. But you definitely don't want to bridge negative and main data, and you don't want to bridge positive and negative, and you don't want to bridge positive and this data. So I'm gonna check continuity on those here in a second, make sure we're good. But right now, I'm trying to find my male plug that I had laid out here, I thought. Because we're going to get the old test rig out. Let me get these. Oh, there it is. I found it. So, I'm going to bring in this male plug. And for those of y'all that don't know, we built a test rig on Megtooth Monday Live. We built a test rig that I used to test Neopixels. And we're going to be able to test these onboard pixels. I'm zooming y'all out with our test rig that we built on Megtooth Monday Live, which is a custom Saber shop MHS V6 chassis with an 18650 15 amp battery, and it has a female plug on it. The cool thing about that female plug is we can plug into this male plug, and we'll connect this haphazardly to the wires we just soldered. So the first thing I'm going to do is test the onboard Neopixels. So I'm going to strip some of our red wire here. Y'all can see I'm still like a testaholic. You know, I'm always testing. I don't even know that we'll get battery and all that crap done tonight. We'll go as far as we can tonight, but I don't want to, you know, go too crazy here. And I'm going to strip some wire there. So there we go. Now let's pretend all these wires that I just stripped. So I'm going to dip them in some flux and we're going to pre-tin all these wires. So the wires that I'm pre-tinning are going to be my secondary data, which is the brown wire that went to data 2, because it controls our onboard neopixels. We will test the main data wire too. And I'm going to solder our red wire, and I'm going to pre-tin our negative wire. And now, oops. Now what I'm going to do is on this connector, the white wire on this male connector is negative. The white wire is negative. The green wire is data, and the red wire is positive. So what I'm going to do, I'm actually going to need helping hands, as if I didn't have enough crap in the way, is I'm going to use my helping hands here. Now I got a camera tripod, helping hands, and everything else. This is our red wire. So I'm going to take a red wire and I'm going to tack this in there. Just like that. And then next I'm going to do data. So I'm going to put the green wire in there. And I'm going to tack the black wire. And then, you know, if this was going to be permanent, of course I would use heat shrink. But this is just a temporary test. I'm going to tack our secondary wire onto the green data, just like that. And then last is our white wire. Oh, my data tack didn't hold. You son of a bee. You're going to hold. And you don't want to, but you're going to. I'm going to load you up with leaded solder, and I guarantee you're going to hold. I guarantee. Bada bing. She held that time. Now we're going to go to the negative wire. I probably should have run that the other way so you guys could see it. I don't know if you guys can see that or not. And now we're going to tack this negative wire here. Boy, damn helping hands almost tipped over. Everything's in the way. Normally when I'm doing this, I don't have tripods and cameras and everything else around. I'm all by my lonesome. So basically, let me get the helping hands out of the way, because we already have enough crap in here. So now we have our Neopixel adapter that we've soldered up. Now, of course, I don't have my main data. We'll do that in a second. But what we want to check right now are these onboard Neopixels on the adapter. So now we're getting ready to see if I'm a hero or a zero. So we're going to plug in our positive. We're going to plug in our plug into our test rig. We're going to bring our test rig out of deep sleep. And we're going to hold these wires apart so they don't short out. I'm going to bring the adapter in and ignite. Ha ha ha! Flash works. Sweet. Lock up. Let's try a different color. There's red. Lock up. Sweet. So the onboard pixels work. We know that. Now, what I'm going to do is I'm going to swap data lines. So now we're going to test our main data. So I'm going to unsolder this temporary connection. And by the way, I unplugged that before we did that. And then we're going to come in here and we're going to strip our main data. And we're going to be able to put this kind of into the Saber maybe and test. So let's see, 26 is my main data. So strip 26. And you know, I glue these things together when I'm putting them together, and I don't know. We'll get as far as I can tonight. I'm talking about the stock adapter. I actually use E6000 to glue them together once I get it solid. But we'll be able to test it tonight, and you can see it working in the hilt. But I won't wire it final because I'll take it apart and glue it. But we're going to put it in the hilt here real quick so you guys can see this hopefully lighting up a 1-inch blade, at least my test blade. So there we go. Now we've wired our, oh damn it, I wired the purple wire, the brown wire again. Somebody probably saw that too. I need the purple wire. Hey Jen Jen. Jen Jen logged on to check on me. I miss Jen Jen on Monday nights. Okay, so now I wired our purple wire, which goes to data 1 on there. And now what we're going to do is we're going to go ahead and temporarily install this in the hilt. So I got to run this in through the adapter, and then I'm going to run that wire in through the adapter. And I'm going to drop all this into our adapter here in a second. Ugh. And let's put the lens on the thing and twist it till it seats. There we go. And then you just pop it in just like that. See, it all snaps together nice and pretty as you please. And then I'm going to send it into the hilt. So I'm sending these wires into the hilt, sending them into the hilt, where, you know, eventually that'll be their final install location. That brown wire don't want to go. Where is my hemostats? I need my hemostats. I can see the brown wire, but my fingers are too big to get in where it's at. I'm going to be where you're at. I got you. And now I'm sending that into the hilt. At any rate, so there is the thing that's installed. I have some work to do. That's not how it's going to look final, but we're just trying to get this quick and dirty for the test. Now, let's see, where is the hilt top? Where did I put it at? There she blows. So we know this is kind of going to go like that. I'm just using this because I need a 1-inch blade holder, and this is how I'm going to get it. And it's going to be kind of screwy because I did this before and it worked out fine, so I figured we could do this on this video. And I'm going to pull those wires up through. This is just testing the blade. Okay. There we go. Now we're going to put our test blade in there. So there are test blades on the Saber. We're getting ready to test our main Neopixel data. So we're going to take this plug and we're going to make sure that all those wires are separate because we don't have shrink wrap on them. And we're going to plug into our test rig again. Keep those wires separate by hand. Actually, it's not fully seated. I'm going to have to hold all this in. I'm having to hold it in because the springs aren't fully seated, but there we go. There's your lockup. Blasters, they're all showing up like they should. Alright, so we know my main data works. So bada bing, that's all the testing. So we know that the stock connector is successful on both onboard LEDs and its main data line for the main blade. But that's that. So now I figured we'd get onto the recharge port. And I want to talk a little bit about these recharge ports, and I have a new one, but you can see the recharge port's already installed in this Saber here, and it's going to be a little bit more difficult putting the wires on while it's in the Saber. I know it's nice etching, isn't it? But I want to talk about the recharge port. There are 3 poles on these recharge ports. This one that says SC is actually the leg that gets cut off when something is plugged into the recharge port. If you can, trying to get it where you guys can see into the recharge port. Inside the recharge port, where you can see now, there is a spring lever mechanism. So when you plug in a charger port or a kill key into the recharge port, it actually springs away the leg for this leg here. And this leg that's etched SC, which is for Switchcraft, the brand of this recharge port, this is the actual leg that gets cut off. So this is the leg you want to run your wire to your Proffieboard for negative. Not your battery negative, your negative that's going to your Proffieboard. This is the one that gets cut off when a kill key is inserted. Opposite of the etched Switchcraft leg, this leg is connected to the center pin. This leg is your positive. So your battery positive goes to this leg that's opposite of the Switchcraft leg. Then the third remaining leg, this one, is your battery negative leg. This one goes to your battery negative. On this hilt, just so you guys are oriented, this is my positive, so that means this should be this cut-off leg and this should be battery negative. Positive because it's connected to the center pin. Cut-off leg because it's opposite of the positive, but also it should be etched, and it is. This one is etched SC, and I can see a little bit of etching even though they cut off the legs. And this one should be battery negative. And so I guess we'll start doing that. I guess we'll bring in a battery. And then I know we're going to need to wire our speaker too, because our speaker wires have to route through there. This is all part of Saber building. So I do know that we need to probably get about a foot long 2x blue for the speaker. And this one takes a flat speaker. This is an older hilt. I'm going to go ahead and wire this this speaker here real quick. Oh yeah, a Saber within a Saber. I don't think we're going to finish the whole thing tonight, Cole. I think what I was just going to try to do is just get some of the main components out of the way tonight. And in fact, once I get this recharge port wired up, we may call it quits. I'm going to get the recharge port, battery, and speaker wired up, and then I think we'll call it a night, because I need to go to bed, because I have a long day tomorrow. Really long day. That's way too much wire, but what are you going to do? Bada bang. And then we'll come in over here. It's called I Need Some More Hands and a little less tripods and crap in my way. There we go. She solidified good that time. Alright, so there's our speaker wired. Now I can twist those wires together. I'm twisting those wires together. Stand by. You guys can see twisting those wires together. Twist, twist, twistaroo. Yeah, so this is probably an older hilt, everyone. This hilt was actually designed for the standard 28mm flat speaker or custom Saber shops premium speaker, as they call it. So yeah, this is TCSS 28mm flat. I had to order it just for this hilt, and they do still make them. But you guys are absolutely right. Nobody uses these flat speakers anymore. But I will tell you this. I did use one in my A New Hope training Graflex, my Mentor Graflex, and you guys never knew it because that thing sounds great with a flat speaker in it. I was actually surprised at how good it sounds because I've gotten so used to the bass speakers. Yeah, some kind of funk going on. I don't know what's going on. But yeah, I may have to end the stream definitely here in a minute. So we may not get to all this tonight, but oh well, at least we got a lot of V4 stuff tonight. Let me get those battery wires where I can get to them. I'm trying to route these speaker wires in here right now, so just stand by. Oh, wire routes are very, very tiny on this thing. So this hilt was designed when everybody was using 30 gauge or 32 gauge wire for everything, and the wire passages are just, I don't think there's any way I'm going to be able to light that with a damn Neopixel. There is no way. It doesn't even want to take twisted 30 down that wire passage. Oh, you're going to go. Because I'm going to take my forceps and jam her home. Oh, you know it's bad when they don't want to go when you're jamming it with your... Figured I didn't want to do... Oh, looky there. I got my speaker wire. Bam. So we've got the speaker wire through the crystal chamber. Oh, Tom. Oh, you know what? We'll just disconnect, we'll desolder the speaker wire. That sucks, because I didn't run the speaker wire through the, where it needs to go. Dum da dum dum dum. Caught live on video doing stupid stuff again. That's alright, we can fix it. We have the technology. I think somebody's sending me messages while we're live. You know, when I'm trying to get ready to go live, everybody's like sending me messages, and I'm like, oh, I'm trying to get ready, guys. Killing me. Killing me. All right. Speaker's resoldered. You guys already saw it once. If I was blocking you, it is what it is. So, you know, the speaker is going to set right there. Let's get the slack out of there. That's where the speaker is going to set. It's very beautifully machined to sit right there just like that, and I'll have to glue it in. And we'll get to that later. I'm going to leave a little bit of slack. So, now, yeah, what are you going to do? So now, this is a custom Saber shop, you know, protected 18650, 15 amp discharge battery. And they come with these, you know, big JST connectors on there. And, you know, this wire that they come with is, I think it's 24 gauge wire, but I'm not going to use a lot of it. So basically I'm going to snip, snip, snipperoo. Only do one wire at a time, because if you were to snip through both of these wires, you're going to make a circuit. That would be bad, because the circuit is short. It's from here to here. You don't want to do that. But there we go. There are our two lead wires, which I'm going to connect into my 22 gauge wires that are already in there in the hilt right there. And what I'm going to do now is I'm going to strip a little bit of these wires. I'm going to, it's 24 gauge, I'm pretty sure it's 24 gauge. And I'm definitely going to have to use some shrink here. 24 gauge there, 24 gauge there. And I want to keep these separate. This is the dangerous part. Danger, Will Robinson. Because, you know, if you watch Mad Cow's videos, you know, he's always covering these things with insulators to protect against a potential short circuit. And because we're live tonight, you know, I'm living life on the edge, which is, you know, very, very dangerous. But I'm not going to touch the wires. Don't cross the streams. Don't cross the streams. Think about it like that. You don't want to cross these two streams. If you cross these two streams right now, it would be very, very bad. So that battery is somewhat dangerous right now because it's live and I got two bare wires, but not for long. Not for long, ladies and gentlemen. I know. I feel like I'm a bad, bad boy. Now, I wonder if I left myself enough wire to get through there. I think I did. It's barely there. If not, I'm going to have another joint inside the hilt. I got to get some shrink wrap. Living dangerously. Living on the edge. Let's see. I think I need this size shrink. I got a big bulk container of shrink wrap. It has all sorts of assorted sizes of heat shrink wrap. It's pretty cool. Got it at the Home Creepo. Yeah, just pray for no sparks while we got all this going on. Positive and negative. And then the good news about is if I do that, then I can actually, let me get some heat shrink going and turn on my heat gun. A little bit of heat shrinkage there, and cut a piece there, and cut a piece there. And we're going to put those on our wires here before we join them, because if not, we won't be able to. And a little twist, twist, twistaroo. Little dip, dip, dipperoo. And then a little tin, tin, tinaroo. Way too much wire. I'm going to have to cut some of that off, but we're living dangerous tonight. What can we say? Here we go. All right, get lost. There we go. Okay, so now, God, this camera is not where I want it to be. So let me try and move y'all. And should I try and do this freehand? We're living dangerous tonight, right? We're going to try and do this freehand, because I would like to get this covered up with shrink so we're not, dealing with an explosive situation here. And let's see if we can pull this off freehand. 1, 2, 3. Oh, 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 look at that, ladies and gentlemen. We got a freehand. Don't go down in the hilt, you bastard. Come on up here. You know you want to go back home. That's where you want to go, right there. And then we're going to bring in our little heat gun and shrink our heat wrap. Now we're a little bit safer. We're a little bit less likely to die because we have that exposed, covered with shrinker wrapper. And now, should I try to freehand the negative too, you think? Since the positive worked out? Yeah, let's freehand. This whole thing could explode right now live, and then maybe my video would go viral. Megtooth Sith dies Monday night soldering battery wires because he didn't listen to Mad Cow. Little shrink, shrink, shrinkaroo. Shrink, shrink, shrinkaroo. The Sabers for Tony, who lives a long, long way away in a galaxy far, far away from me. But I built quite a few sabers for Tony. He's a massive saber-holic. He would fit right in here. But I think he's too busy to watch live videos. Damn. Positive's not going to be long enough. Crapola. Mother and country. Doesn't that just suck? Look, my positive is just barely not long enough to reach. Oh, it might reach. Oh, you guys couldn't see it. Shit, had it off screen. My positive is just barely not making it. Let's see here. I have a little bitty 22 gauge wire here, so I'm going to do a magic trick. Because I need a pigtail to join to all my other positives, so I'm going to do that right here. And I'm going to go ahead and strip this positive. Hopefully Let me clean that up because there's some solder on there, because I want to be able to get the jacket up past it. And I'm going to strip this 22 just like that. And I'm going to try and extend it. Going to try to do the little trickaroo here. And we'll use shrink to cover this joint. It's just barely not long enough. I was trying to use some scrap wire there and didn't work out. Didn't work out for the beaker. Although I should, I'll put shrink on this before I do it. You guys will see what I'm doing here in a second. Basically just trying to extend out the wire just a hair with my joint, and I'll cover all this with heat shrink. There we go. Now let me pre-tin our positive pad down here. And then we'll put some heat shrink on this positive pad. It'd be nice if I could get the solder in there. I know you guys aren't going to be able to see this, but with this recharge port already in there, normally I would install a recharge port outside of the hilt. And I know this looks a little crazy, but it won't when I'm done. Because we're going to use a longer piece of heat shrink here to cover up that disaster that I made there because my wires were too short. And let's try to come in here for the kill. I don't know if you guys are going to be able to see this, but I'm going to solder, hopefully, this positive wire to my recharge port. Oh man. One, two, three. She's on there. Looks like I have a little errant wire there. And then we'll bring in the shrinkaroo there. And shrink that up. We'll know if it's successful here in a minute. Then this is my cutoff, so I know this is my battery negative, and it looks like my battery negative will have a little bit more spare, but not much. And then we can hook this up to a recharge port and test it. Alright, let me pre-tin the battery negative there. No, it's not a solder jumper, Bobby. It's actually that spare wire. I actually stripped that spare wire down so it reached the other wire, so that's why I had so much stripped wire there. Was I needed to get that wire to the recharge port. So it wasn't solder. That's actually on there with the wire. Alright, see, now we're getting to the point where too many freaking wires are in the way here. Definitely not going to get to the switches tonight. Now let me try to bend this where it's going straight down, and I need some shrink wrap on this, and I'm going to cut the shrink wrap on an angle before it goes around this post, and I'm going to cut it there. We're going to pop it around there. And then I'm going to need my hemostats because this 22 gauge wire heats up pretty fast and it's hard for me to hang on to it. So it's a lot easier with hemostats. I don't know if you guys are going to be able to see this action in there, but let me solder too. Let me butter up my iron here. Get a pretty good amount of solder on my iron. And try to bring in this wire. Hopefully y'all can see it. If I'll try to angle it your way so you can see what I'm doing here. But lighting's going to be tough. That looks pretty good. There's some spare wire past the end there. I want to cut that off. It's kind of hard for me to get at it. Then we're ready to put our shrink up over that. So I'm bringing our shrink down that we put on there a minute ago that we cut that angle cut on. We'll put our shrink wrap over that port and down, covering as much of it as we can. And then we're going to shrink, shrink, shrink-a-roo. And then while the shrink wrap's hot, I'm going to bend it where I want it. Like that. And everybody makes fun of us because we're nerds, including my girlfriend. Jenru, she checked in on the live stream a little bit ago, and she's like, are like all those people as nerdy as you? And I'm like, yeah. I'm like, and it's okay. And she knows, she loves the fact that I'm a nerd. You know, and I'm cool in my nerddom. I embrace it. I know I'm a nerd. You know, I mean, who's soldering on lightsabers to make a stupid movie prop come to life? You know you're a nerd. I am definitely not an adult film star. I'm trying to solder this cut-off leg on there. There you go, baby. You know you want to take it right there. Exactly. I'm not a big adult film viewer. Never really got into that. But to each their own. However you can make money to get lightsabers is a good thing, right? And I'm sure if he was a good adult film star, he might be able to afford more lightsabers than me. So hashtag nerd up. Teach your own. Alright, so now we're at the point where we can test this recharge port, right? So our little pigtail red here and our little pigtail white here, we don't have anything in the recharge port, so I should be reading battery voltage on there with the handy dandy voltmeter. So I'm going to strip our 22 gauge wire. Now we're back where, you know, Mad Cow would be mad at us. I'm stripping my white wire and I'm going to strip my red wire. And where's my multimeter? And let's put some alligator clips on my multimeter. We'll make it as safe as possible. Safe as possible. You never know who's going to drop in, y'all. I'm sitting here trying to solder a lightsaber, and y'all are talking about 2 quarts something or another. Alright. Let's get the multimeter in here. What I'm going to do, hopefully you guys can see all of this. It's kind of crazy. So I'm going to switch to DC volt 9, and you can see it's reading 0 volts here now. Now this white is supposed to be my cutoff for the recharge port, and I'm going to hook it to my black lead, and I'm going to hook this red pigtail to my red lead, and hopefully we get voltage. And we don't. So that means done something wrong here. Wow. Epic fail. 0 volts. That can only mean one thing. That means that when we have broken a connection in our battery connections. Has to be. Has to be. Or I've broken a wire inside of there. I don't understand this now. Let me do something here. Let me pull back this insulation. So let's do a direct connect here and bypass the recharge port altogether. So there's my red probe and my black probe I'm going to put direct to there. And we've got nothing. So I'm right on my black wire and right on my red wire, and I'm still got no volts. So I've either got a defective battery or something going on here. So wow, major foobar situation there. What are you going to do? That's why the multimeter is so handy, because, you know, had you installed this Saber going, oh, I wired all that correctly. No, you didn't. But this gives us a chance to put longer wires in and do this right anyway. So let's just disconnect that. And cut the strip, because, you know, don't cross the streams. And we're going to pull all this crap off. And we're going to desolder that wire right there. And I think I'm just going to cut this, because I'm probably going to add longer wires on there anyway. And let's pull all this out. So here's my battery. And I've either pulled out something or something's wrong with this battery. So there we go. I did not break those wires. So let's bring in the multimeter here and find out what we've got going on the battery. Go direct in. Going to connect in there. And we're going to connect in right to, ooh, don't cross the streams. No volts. Well, have you ever seen a custom Saber Shop battery arrive with no volts? Huh. That's highly unusual. Never seen that before, ever. Bad battery. That totally sucks. I'm hooked direct into the battery now. 0 volts. So I had 0 volts all through the system. I've tracked all the way back to the battery. I'm at 0 volts in the battery. Yeah. Now, this is brand new, fresh out of the box, custom Saber Shop battery. That really sucks, because I figured I had everything connected right. I did a lot of prep work. Let's do this. Let's break out another brand new custom Saber Shop battery. I'll show you it's new in the packaging. Stand by. Let's get all this danger stuff out of here. Danger, Will Robinson, live wires with no volts. Brand new in the packaging. The joys of saber building, dude. So you want to be a lightsaber installer, and you go to buy things like this that cost a lot of money, and then they're, you know, foobar on delivery. Yeah. I get to spend another $15, but the customer never sees that. The customer just knows that they paid 15 bucks for a battery. They don't know that I paid 30 for 2. Now I might be able to rehab that battery. Maybe it just totally dead, needed a charge, but who knows. So here's the brand new battery. We just stripped those wires. Let's hook on direct. I didn't figure I needed to test a brand new custom Saber Shop battery. Looky there. 3.38 volts, which, you know, I expected that. Yeah, I'm going to try and recoup that battery and see if I can fix it. But I just wanted to make sure my multimeter was working and everything. No, Jeff, this was, I got these in about a month ago. It's not that old. It's pretty fresh. Oh, well, the best laid plans of mice and men. But sometimes, you know, y'all remember what Yoda said, right? What did Yoda say in The Last Jedi? And sometimes when we have failures like this on my live streams, well, it's frustrating and depressing, and you're like, wow, we did all that work, and we had the Saber almost ready to install, and we had to tear the whole damn thing apart. Because of this. But the fact of the matter is if you, I think the key lesson tonight is use a multimeter. You know, failure is a good teacher. And when you're building lightsabers, you're going to run across problems like this. And this isn't the first time we've run across a problem in the live video. And, you know, we're well past an hour. We're at an hour and a half. I'm tired. No, the meter wasn't on hold, Bobby, because I tested a new battery and it worked out good. But, you know, I get everything to the point where we test it, and when I test it, I'm not getting what I'm expecting. And if you're not getting what you're expecting, you need to stop and start going backwards, which is what I did. Something's wrong. Maybe I pulled one of the connections out of the battery, but we went all the way back to the battery, and I didn't pull the connections out of the battery. They were still intact, heat shrunk, and solder still intact. And I hooked the meter right onto the battery, and I'm not getting what I expect out of the battery. I didn't test the battery when we first pulled it out of the package and stripped it, but I've never ever got a battery from TCSS that was showing 0 volts. But basically, this is the Saber we were installing when we last left off, and I'll have a story to tell about the battery. New battery's already in there. We're wired where we should have been last week, and I got a kill key in the recharge port because she's live, ladies and gents. So tonight what we're going to do is we're going to finish wiring the switches, and we're going to wire up the Neopixel that's going to go in here to light up the crystal chamber, and we may do the positive splices here tonight, which I'll show you how I do that. I'm actually going to splice the positive battery line into the positive Neopixel connector, and then the positive coming out of the Neopixel crystal chamber, and we'll splice all that together and weld it all together and tuck it down in there. But we got to do our switch wires first because I can't have a mess in there before we do the switch wires. But did some copper cladding on the battery, pretty cool stuff. But at any rate, hashtag nerd up, all wired up, and we had no joy. And I'm going to explain to you what happened. So last week when I wired my recharge port, which by the way, the first time we did it, it was wired correctly, and then we traced it all the way back to the battery, and we weren't getting voltage at the battery. So what happened, if y'all remember, I was living life dangerously and doing what the master said not to do, and that's the, you know, Tim, or the custom saber shop video guy. Y'all bear with me because I can't believe I can't. Mad Cow, Jesus, Lord have mercy. Mad Cow said never to leave your battery contacts exposed, like I did in the video. Remember, I was joking we were living dangerously. So what happened is my positive and negative wires that I had loose willy-nilly, hanging out. You know, if you remember, I had them exposed, and what happened is they obviously at some point or another they touched each other, and then it tripped the battery protection circuit. So these protected batteries have a battery protection circuit in it, because if you'll remember when we put the voltmeter on it, we weren't getting any volts. So basically what I did, and here I got a battery to show you. So this is very similar battery, and this is the video we had in last week's video. And there you can see I have my wires exposed like you don't want them to be exposed, because if those two wires touch each other, they'll trip the battery protection circuit, which is precisely what happened. So how do you fix that when the battery protection circuit is tripped? Well, all you got to do is plug it back onto a charge circuit, and the charge circuit will reset the battery protection circuit, which is what I did. The battery was fine. It's fully charged. This is the same battery we fully installed. You get out the multimeter, put it in volts where you guys can see it, hopefully. And I'm going to probe this battery with the recharge port unplugged. So I'm going to go positive on the center post and negative on that, negative, and 4.21 volts. So there you can see we're fully charged now. because we're working on the Saber, I don't want a live battery, so I'm putting this kill key back in there because we don't want to be working on a live battery. But there you can see that the battery works. It's hardwired into the recharge port, and we're done. So down here we have these two switches. Now I didn't install these switches. Whoever put these switches in, it wasn't me. But you can see that each of these switches has four legs. So this leg is contiguous with this leg, and this leg is continuous with this leg. Now then they installed this other switch the opposite way, which is a little weird, where this leg is contiguous with this leg, and this leg, and then this leg and this leg. So what I'm going to do is I'm going to tie these two legs together, and that'll be my ground circuit for the switches, is tying those two legs together. And I'm going to solder them together and solder my ground wire to those two legs. And then I will make this my aux switch leg, which that'll carry the yellow wire. And then I'll make this leg the main switch leg right here. So these two that are tied together will be ground. And then the opposite side, which isn't contiguous, because if I wired the one here, that's not good because that's ground. So I need to wire my positive or my green wire here for our switch, which is opposite of this leg, is this leg. And I'll show you a picture that explains all that. And then I'll wire my yellow wire, well, I'll probably wire it to this leg here because it's more out of the way. And then I'll have my yellow, white, and green wires, which are my switch grounds, which are shared by both switches. And then the green wire will be to my main switch, and the yellow wire will be to my auxiliary switch. And that's how we will wire them in. That's how we'll get it done. But these switches aren't glued in. I wonder if I could rotate them. So at any rate, that's kind of the plan tonight. And then after we do this, we're going to wire a Neopixel, an accent pixel, which is going to go, let me zoom out so you guys can kind of see what we're working on. Whoa, it's a slow zoom out. Okay, so on this Saber, it does have a crystal chamber, which is right here. And on the underside, which I don't know if you're going to be able to see, is a place for us to put, you know, an LED or a Neopixel to light up the crystal chamber. And we're going to put a Neopixel, a single Neopixel in there. And I guess I'm going to run it to its own separate data line. So we'll have 3 blades on this Saber. We'll have the stock connector LEDs, which I showed in the first video, which their data is that brown wire. Then I have the main blade, which is purple data. Every one of these lightsabers is different. Just because I'm installing this Saber this way doesn't mean it's the right way. It's just the way it works. Let me see if I can rotate these switches so they make more sense to me without breaking them. Oh yeah. Oh man, these switches are so fragile. I have more switch 22s if I break one, but I'm trying to do it without breaking them. These things are so fragile. So the switch popped out of there. I'm trying to pop the switch back into the hole. Get in the hole. Find the hole. Don't you want to go home? There we go. Okay. So there you can see the switches in there. And what I'm going to do is I'm going to merge these 2 legs into one. And those will be my grounds. I'm going to solder them together, and there'll be shared grounds on both switches, and they're touching pretty good there. Let me get the soldering iron heated up here, and we'll get the soldering iron heated up, and let me get some wires cut and get down here. We don't need a whole lot of length now on these switches. I use 30 gauge because, you know, switches just aren't carrying any amps, and 30 gauge doesn't take up much room. Okay, so I got some wire there. So now what I'm going to do is I'm going to come in here with some solder, and hopefully y'all will be able to see what I'm doing here to these switch legs. So you can see these 2 switch legs here are pretty close together. I want to get them closer than that because I'm actually going to solder them. And they're actually touching there. You can't see it, but they are touching. And we're going to bring my iron in here. And we'll bring the multimeter in here too to check for continuity so you can see what I'm telling you is the truth. Okay, I think we got a good connection there. So that's what we're going to do next. We're going to bring our white wire in there. And I'm going to strip some of our white wire. And these switches are so fragile. Their custom Saber shop calls these switch 22s. And I'll show you a picture here on the internet in a minute about how to wire these, these switches properly, because everybody always asks, well, what leg do I wire to what? And it can be confusing because you have 4 legs on these switches, but you actually only are using 2 of them. You're only using 2 legs. Now I'm not going to put shrink on this before I go onto my solder. I'm going to do it after I solder on. So I've already tinned my wire. I did that off camera, so I'm sorry you guys didn't see that. But you should see our wire coming in here. And let me try to get y'all where you're in frame where you can see this. There we go. She don't want to stay there, does she? Let me zoom out a little bit. That might help. And of course the leg of the tripod is exactly in the way, but I'm going to bring that wire down and hopefully join. This is our negative for both our switches, because remember we joined both those legs, so this is the negative for both of our switches. Bada bing. So that's our negative switch leg. Now I need some heat shrink. I move the camera to the left. The problem is, Max, is we're shooting down in there, but I joined those 2 legs on those 2 switches and soldered that wire on there, and I don't know that you're going to be able to see it that good. This is kind of really super small stuff that we're working on. But at any rate, I'm going to cut a fairly large piece of heat shrink here because I want it to be able to get down over those switches. But I'm also going to cut a small piece of heat shrink, try and grab as much of that joint as I can. And the small piece will help merge my white wire onto the bigger heat shrink, which I'm going to drop down. So there's actually, you know what, that small piece of heat shrink is going to cover. It's going to go over the legs and everything. So now I'm bringing my heat gun and I'm going to shrink wrap that connection. And then while it's hot, I'm going to fold it out of the way because I want it out of the way. And if you guys can see, I did that same thing on the recharge port. I folded the hot shrink wrap out of the way. So that's another trick, is if you just bend the heat shrink while it's hot, that gets the wire kind of out of the way and sends the wire the direction you want it. So let me try to find this. I want to try to find this switch diagram on the internet. So if you go to Google and you Google, I need to share the page, stand by so you guys can see what I'm doing. So I'm going to leave that in there and let's go back to Google. And I'm going to Google tactile switch wiring. Let's try that. There we go. So this picture here, let me see if I can pull this up. Okay, So this switch, each of these tactile switches has 4 legs. And you can see the 4 legs here. So remember, this leg is not connected to this leg, but this leg is connected to this leg. You can see it's internally connected. So what happens is when you press the button, then the legs get connected. So what I did is I connected this leg to one switch to that same leg on the other switch. But that means then I need my green wire on the leg of on this leg of the other switch, and then I would need the yellow wire on the leg of the other switch, which is what we're going to do. That means the 2 switches are sharing a common ground, but each switch has its own independent switch wire. So that's what we're doing right now. And I know this seems a little bit confusing, so, you know, that's kind of what's going on here. That's why you don't need all 4 legs on these switches. So let me go back to the whole full caboodle here. So in that video, this leg is connected to this leg. This leg here is connected to this leg, and this leg is connected to this leg, and this leg is connected to this leg. So now I don't need this leg or this leg because they're already connected via the white wire. So I'm going to trim them, and off they go, because we're getting them out of our way because we don't need them. And I'm going to shake the loose pieces of switch out of there, and bada bing. There we go. So now what we're going to do is this forward switch here, this one right here, is going to get our green wire, and I think I'm going to wire my green wire here, and I'll wire my yellow wire here, and that way I can get rid of those 2 legs. And then I got to figure out a way to permanently adhere these switches in there so they don't push out. I don't like using super glue on these switches because the super glue can get into the switch mechanism, but you know, I'll figure something out. It may not be tonight. Put some fresh solder on my tip, and we're going to bring in the wire here. This is crazy because I'm trying to do this in frame, which is insane. But there we go. So that wire, our green switch wire, soldered on, and I'm going to cut a piece of heat shrinkage. And I'm going to drop some heat shrink down there to cover that switch post. Just like that. I don't know if you guys can see that, but now I have that wire covered in heat shrink, which I'm going to shrink it up. Shrink, shrink, shrinkaroo. We're off to the races. And while it's warm, I'm going to bend her over so she's out of the way. And then I don't need this other leg. I don't need this other leg, so I'm going to cut it off. Bada bing. So we don't need that leg. Now, I think what I'm going to do is wire our yellow switch wire, which is our aux switch, onto this leg. So I'm prepping it, and let me see if I can point it out here so you can see which leg we're going to. We're going to this leg right here, which from your perspective looks like it's touching, but it's not. You can see it's pretty far away. So we're going to be going to that leg here, so we're going to pretend. Well, it's even harder, Max, you know, when I'm having to work around the camera, because normally, you know, I wouldn't have the camera and the tripod right here. And normally I also wouldn't be sucking in solder smoke like I just did there. But, you know, it's all for the sake of YouTubery. And really quick, I know sometimes, because me and Jen talk about it, sometimes I might sound like this is the only way to do it, this is my way, this is the best way, but it is not. It's just the way I do it. You know, you'll develop your own style, and you might find something that I do is screwed up, and you don't like it. You don't have to do it that way. There's a bunch of different ways to get this done. You know, right before I went live tonight, I was out working on my trailer lights, and I found a short on my boat trailer lights, but I didn't have time to fix it because I need to get in here with you guys, and I got other crap going on too, so my job is really making my life difficult at the moment because pretty much don't have any time to get my stuff done, and you know, still get in here to hang out with you guys some. But so now we're gonna send some shrink wrap down this yellow wire and over the switch. I might have to do this off camera because I can't see it. Oh, I found it. Get in the hole. Don't you want to go in the hole? Alright, so now we're heat shrinking our yellow wire. And we'll bend it over while it's hot. That's what you got to do. You got to bend her over while she's hot. We're going to bring in the handy dandy multimeter. And what we're going to do is we're going to do a continuity test by depressing these switches, and we should hear tone like that on the multimeter. So let me strip some of our switch ground wire, and this is our switch ground wire, 30 gauge. I'm going to strip some of that bad boy right there, just like that. I'm going to twist her, and I'm connecting the black lead. This is the black lead, the negative lead, to our multimeter onto that switch wire, and I'm going to fold that switch wire over it so we have good contact. And then we're going to strip our green wire, which is our main switch, the front switch wire. I always make my front switch the main switch, but I've seen people do it opposite of that, and it doesn't matter. I mean, you do it how you want. Now I'm going to take my red lead, alligator clips from my multimeter, and I'm going to hook it onto the green wire, and I'm going to fold that green wire around the alligator clip. Now we're going to turn over our lightsaber, and we're going to press this forward button. We should hear a tone. We've got tone. Fire it. So we know that our main switch is wired correctly. Now let's check our auxiliary switch. So we're going to strip some auxiliary switch wire here and twist it, and we're going to connect our positive lead. I've left my negative lead connected to our ground white wire right here, and only lead I'm switching is my positive, and I'm putting it on our auxiliary switch wire just like that. And then I'm going to turn this saber over, and I'm going to hit the back button. We've got tone. Fire it. So, bada bing, the switches are wired correctly now. Really solved. The soundboard obviously has to go here, and I don't like the soundboard being mounted on metal, so probably what I'm going to do is I'm going to be mounting plastic straps across here, and then I'm going to put a Proffieboard multi-board adapter, a plastic 3D printed one, in here to hold the Proffieboard. And then I'll probably secure it with E6000 onto the ribs that I'm going to glue across here, plastic ribs. It's all going to be plastic because there's really no other way to mount this. Ooh, and by the way, we can cut off that other leg from that switch that we don't need. Bada bing, it's out of the way. Our switches are wired, so we're ready to go there. Now we need to wire the Neopixel that's going to light up our crystal chamber. So we're going to do that right now. So anytime we're doing Neopixels, you know, we have 3 wires. Positive is going to be red, negative is going to be black, and orange is going to be our data. And, you know, I cut those all different lengths because we're doing this quick and dirty here for the internets. You can see that the strip arrows are running this way. I don't know if you guys can see that on the video. So if that's the case, then I don't have data pads or positive or negative for this pixel. So I know that pixel is junk. So what I'm going to do is I'm just going to cut that pixel away, which leaves me my data pads. And you can see here, I'll try to point it out, but this one's going to be negative, the center is data, and the outer one is positive. I'll zoom in on them here in a bit. Now I'm just going to use 1 pixel for the crystal chamber. So I'm going to cut just after the pixel. And that leaves, you know, data pads on this strip, which I can still use again later. And now we have our Neopixel down here. So I'm going to try and zoom in on this puppy for you. It's time for a new mat, because this mat is toast. There. I'm all opposite because it's crazy. But I'm trying to zoom in on it. But you guys can see how small that is, right? I'm going to get my solder out. And this is a cut-off piece of Neopixel. Now, you guys can buy those Neopixels on PCBs that are already mounted or whatever. But, you know, I make so many lightsaber blades that I have so many of these spare Neopixels. On crystal chambers, I just use these Neopixels like this. Because to me, it's cheaper, it's easier, it's golden, it doesn't matter. Now, it probably would be better, now that I'm thinking about it, for us to solder on the back side because of how the wires are going to route. So I almost made a mistake right here live again for you guys. But I'm going to pull the adhesive off the back side, and I'm going to get rid of the, you need to get rid of the adhesive on the, you need to get rid of the adhesive that's stuck on the back of the Neopixel. So I'll take a hobby knife, and this hobby knife has seen better days. I think I have a better one in here. But I'm trying to get the adhesive started, just like that, so I can get the adhesive off. Because if you're trying to solder onto that adhesive, good luck with that. Now, this is going to be positive, this one here. This is data, and this is negative. So what I'm going to do is I'm going to pretend these suckers. Let me clean off my soldering iron tip. And let's pretend each pad. Normally I like holding these things in a holder, but if I do that, you guys aren't going to be able to see it. But there you go. Now each pad on the Neopixel is tinned. Now I'm going to flip it over and make sure that I'm not crazy. Positive is on that side, so it's going to be opposite when we solder. Yep. So positive should be on this side. I'll point it out to you with a razor. That should be positive. Right there. So that's where we're going. So off camera, because y'all are zoomed in and you're not going to be able to see this, but I am stripping wire. I am stripping wire. And on these, I don't strip a whole lot. Let me try to get in there where you guys can see it. I'm not stripping a whole lot. I'm stripping just a little hair piece. It's zoomed in so much it's not going to focus. But you can see, and that's probably too much, but I don't strip a whole lot off these. The big mistake I see a lot of new guys making is you're stripping too much of your wire, and when you leave exposed wire off the pad, that's an open invitation for shorts, and that's bad, and you don't want that. So I pre-tinned my wire. Now I think I'm going to shorten it a tad bit more, and we're going to come in here for the kill, hopefully where y'all can see it. And try to get this thing centered a little bit more for y'all. There we go. Alright. Positive wire to positive pad. Do this where I keep it in frame and you guys can see it. Hopefully. Shaky hands. Hello, shaky hands. Have some more caffeine, Tom. Bada bing. And then the last wire is my black wire. I haven't ordered batteries in a while. Bada bing. Oop, did you guys see that? Alright. So now our NeoPixel's wired. So basically what I'm going to do is, now that that's wired, I'm going to twist these wires together on this. And I didn't cut the wires exactly even, so I'm just going to cut them there. I shouldn't need more wire than that. And there we go. There we have our NeoPixel. Now, what I'm going to do to test this is what you guys have seen before. You guys know I'm a test-a-freak. I don't like wiring or putting anything in the Saber that I haven't already tested to make sure it's working as it should, and this isn't going to be any different. So now that we've wired our NeoPixel, I'm going to solder on a test plug, and I'm going to test this NeoPixel and make sure it's working right, because it could be a bad pixel, you know. I didn't test that strip before we did this, so you know I have to test this NeoPixel. So what I'm going to do is I'm going to solder a NeoPixel plug on this, and then I have my test rig, which I can use to test this single NeoPixel. So I need a test plug. If y'all remember, we wired the orange wire to data. And let me pretend this orange wire here real quick. And this is just temporary. I'm just tacking this temporary so we can test the NeoPixel. And then next is going to be my positive, and pretend that positive, and let's try and get these tacked together. Normally I'd use helping hands, but I'm trying to avoid bringing more crap into the picture here, but this could be impossible. And I'm not heat shrinking this because I'm going to hold these wires separate as I'm testing this pixel, and the only reason I'm doing this is so I can test the pixel. That freaking wire, I hate this crap. This Chinesium crap that they put on here is crap. Chinesium wire. Alright. There, that's done. Now, let's do the negative, which hopefully the negative's not going to be as big of a beast as those were. Pretend. Of course you're going to be a bitch, aren't you? Yep. You're not going to cooperate. So, I ain't going to bring the helping hands in here because there ain't no way. Ain't no way I'm going to bring the helping hands in here, because this is already a disaster as it is. And I'm going to just quick tack that wire onto there. Alright, so now my plug's on. Now here's what I'm going to do to keep the plug separated. So those wires, they need to be separated. So I'm actually going to use my forceps to keep them separated like that. Okay. Now let's flip this sucker over so you guys can see the NeoPixel. And then what I'm going to do is I'm going to bring in my test board, which this is a Prism 5.5, and I've got a female NeoPixel test plug, and I'm going to hook it onto our NeoPixel here. And then let's boot this baby up and see if the NeoPixel fires. Here we go. Oh yeah. Let's test lockup. Now we're testing different colors. There's blue. There's lockup. So we know the pixel works. So now I'm going to disconnect from my test rig, and now we know that that NeoPixel is ready to go light up the crystal chamber. Here's the test rig really quick. We built this on a Megtooth Monday Live. It's got two simple switches there, 18650 battery there, and of course a female plug so we can plug in NeoPixels and test them. And you know, it's got the bass speaker there. It's basically just an MHS V6 chassis with a Prism 5.5 connected to a negative NeoPixel plug, and that enables me to test NeoPixels and all kinds of other crap. Let me bring the Saber back into the picture here. Let's see what time it is. It's almost time to leave this, so what we may have to do is pick up next week. But I think what we're going to do next week is we'll take this NeoPixel that I'll have installed. I'm probably going to glue this NeoPixel in here with E6000 and secure it in there where it's supposed to go. I think what I'll do this week is I'll put the plastic pieces over here that we're going to glue our adaptive chassis thing to. And of course I'm going to desolder this plug off there because we don't need that plug on there anymore. But that's kind of, you know, that's my thought process in wiring, is from the top down. So last week we're installing this Saber, which, you know, of course it looks like a mess like all my installs initially do. It looks crazy, you got wires all over the place, but we're going to turn this nice and neat, where all you see is a little Proffieboard right there and nice neat wires, and you won't see any of that insanity. And it'll all work. The NeoPixel crystal chamber will light up, and this will light up, and the blade will light up, and it'll be awesome. It'll be doing awesome stuff. So this is the Saber. The big thing we got going on, let me try to level out this thing here. The big thing we got going on tonight is we need to merge. We're going to take this positive line. This is my NeoPixel positive line. I probably need to tape these wires. So we've got this red wire, which comes from our NeoPixel. So it's coming from the NeoPixel adapter. This is our main positive feed for the NeoPixel adapter. This red wire is coming from the positive on the battery to the positive on our recharge port, our 2.1 millimeter recharge port right there, which I got a kill key in it because we don't want to work with a live battery. So kind of what we're going to do this week is kind of what Max is dealing with right now. I'm going to merge this NeoPixel wire with the positive coming off the recharge port, and I'm going to take the positive coming off the battery, and I'm going to merge it with two things. Number one, I'm going to merge it with the positive wire from our little single accent NeoPixel we made last week. So the red wire on this NeoPixel, which I still have to desolder from our test plug, and so my NeoPixel accent positive is going to be here, but we're also going to strip a little bit of this 26 gauge red wire, and we're going to put it in there. So I'm going to have 3 wires on this one merge on this side. So I'm going to have our NeoPixel positive, our pigtail that's going to feed the board, and the positive from the battery. They're going to be twisted together and soldered, and then I'm going to have our positive coming off the recharge port and our positive from the NeoPixels. They will be soldered together here, and then I'm going to join all of those together into one positive merge. So that's kind of what's going on here. The one thing that's, you know, worrisome about this Saber is this pixel is actually going to be going into the Saber and touching metal. So then you have the possibility of a short between these pads, between positive and negative. And, you know, if metal touches this resistor, that could be bad. So before I shove this into the hole, probably what I'm going to do is insulate this with E6000 or hot glue to insulate these pads. And I'm not talking gobs. I'm talking very little bit of hot glue or E6000 just to cover those pads so that this is all insulated before I put this into the hole in the crystal chamber. And I did not do that, but I don't know if y'all can see that hole where the crystal chamber is down there, but it goes... This pixel is going to go down in there. Now I haven't secured the pixel yet permanently, and I'm kind of glad because I could show y'all and make sure to remind y'all about you know, making sure that you don't that you protect these pads and insulate them from touching the metal hilt, because this is going to affix right into the hole on the metal, and so it's going to be contacting metal, so you want to protect against shorts. And I'll do that when I do the final install. But let me go ahead and desolder this test plug that we put on there last week. I kind of left everything at the same place we were last week. I didn't have much of a chance to do anything else, or else I would have glued this pixel in. But we're going to pretend this pixel is already glued in place, so I'm going to get it about where we need it, because I need to get the red wire out of this bundle, because we're going to be soldering that red wire on. So it looks like I need to get it back to about right there. So again, you know, I said when we were wiring up this pixel I probably used too much wire, and I did. But now I've got my red wire out of here, and I can tape those other wires back as well, the orange and black, which were my data and negative for that one. And we're going to work on the config file tonight, so hopefully you'll be able to see some more of my insanity. So now what I'm hoping is we have enough slack in this red wire where we can pull this off tonight. I think I left enough slack to do it, but you know, we're about to find out. So I'm going to find a good place for this merge where I can shove it down in there, and I think we're going to try her right about there. So the first thing I'm going to do for this merge is I'm going to, and if I don't have enough wire, you know, we'll still be able to work this out, because I'll just solder a new red wire onto the recharge port. And I'm going to leave some extra on this just in case we have to do that. So I am going to leave this Neopixel positive wire long because I don't want to have to go back in there and unassemble all that. So it will be a little bit long, but I'll be able to tuck all that stuff in there. I'm going to strip that back. Hey, chat. I could heat shrink that Neopixel coal, but I think I'm just going to use hot goo. Just as long as you use something that's going to insulate it. I suppose you could heat shrink it, but I think the biggest worry when you're heat shrinking is that, you know, that you're going to cover the pixel up. That would be my biggest worry. All right, so I've got our first two twisted together there, and I'm going to put a little bit of flux on there. And actually, that got a lot of flux. Looks like a big old fluxing mess. Big old fluxing mess. Happy Bone. Sweet. Good to see you, man. Yeah, it's been a while since you've been on the stream, but thanks for joining in tonight. So we're doing preparations for an install on a Proffie 2.2. And I know that Proffie 2.2s are hard to find right now, but here's a little secret for those of y'all that don't know. KR restocked today, but I bet he's already sold out. But he did restock today. Okay, now I know I'm going to need about that much wire on my accent pixel. So this is the 30 gauge accent pixel wire. I'm going to go ahead and cut it, and I'm going to strip some off of that. This is 30. Remember, I used 30 for the accent pixel because, you know, one pixel, it ain't carrying a whole hell of a lot of amp load. And then this is the battery positive direct. So I'm going to strip this. This is 22. Bam. Just like that. And I'm going to twist these two wires together, and then I'm going to have to add in my final pigtail wire. So I'm going to show you all why I do this on the diagram. And this isn't the only way to do this. There's several ways to deal with all the positive lines. But to me, this is, you know, and of course the 30 gauge always wants to be a bitch. So stand by. Let me separate some of these strands because 30 wants to misbehave as usual. 30 is so thin, it's hard to get it. So sometimes I put my needle nose. My needle nose have some serrated edges on them, and sometimes by using those serrations I can get the 30 to take a twist. Now I'm going to take this pigtail. This is just a piece of red 26 wire, and I call it a pigtail because it's going to be included in this positive joint. It's going to be included in this positive joint, and this wire will actually be the positive going to my Proffieboard. That's why it's called a pigtail, because we're leaving an end of it loose that we're eventually going to connect into the Proffieboard to be our main positive. So now those three wires, my accent Neopixel for the crystal chamber, my main battery positive feed, and my pigtail are all joined. And now we're going to solder them. And making sure that solder flows into that wire nice and good. Now, we need some heat shrinkage. heat shrinkage, trying to keep up with y'all's questions. Yeah, KR Sabers definitely restocked on some Proffies today. They only have the black ones. Yeah, 30 gauge is a pain in the butt. I actually have a dark saber that was from Solo's Hold. Evan Roseman, Solo's Hold, actually designed a blade. There's video of it on my channel, and I installed it. And I do have one that I'm going to be selling, but, you know, I got to finish all these installs that are pending on my bench first. So I'm putting heat shrink over those positive lines. Yeah. Always trimming, always trimming. Always in motion, the future is. Yeah. Never his mind on where he was, what he was doing, Adventure, excitement. A Jedi craves not these things. You are reckless. He's too old, much too old to begin the training. Alright, let's try this disaster again. Trying to find a good place to join them. Alright, hopefully that's in frame so you guys can watch this disaster happening. I really need helping hands in here, but it's going to be hard for me to get helping hands up in here because of the camera thing. French fried fingers is exactly right. That's exactly what we're doing here. Cole's getting his steps in, and Tom's trying to French fry his fingers. Adventure. Excitement. Now I know that looks crazy because that's like a lot of stuff there. But this merge, we're going to shove it down in there. This merge isn't moving back and forth. It's going to be solid there. And these merges are just fine. Now, we're sliding our shrink wraps over the merge. And there's actually two pieces of shrink here. Now I'm going to try to get them both as far as I can. And then we're going to shrinky, shrinky, winky, winky, shrinky, shrinky. Okay, now I want all these out of the way. So I'm going to push this merge down while it's hot, including that positive wire that we left probably too much, but we're just leaving enough in case we screwed up. But I definitely want to push this wire down there around our stuff. Just like that. So this is the positive wire that's going to, let me back out of here because I'm zoomed in. Basically what we've done is we've merged all our positives down here. And so we've got the positive from the recharge port, the positive from our Neopixel adapter, the positive from our accent pixel, the positive which is going to feed the Proffie, and the positive from our battery. All merged together in one junction. One foul swoop. So, and our merge will live down in there, way down below the Proffieboard. And the only thing we got going to the Proffieboard is this one wire. This one wire feeds everything positive. But the amp load is going to be in this joint for the main blade and for the Neopixels and everything else. The only thing this feeds is the Proffieboard. And remember, the Proffieboard, you know, it's like, I don't know, not even half an amp. It doesn't draw anything. It's just not drawing electricity. Alright, so now we're going into Google. I'm hoping you guys can see this. and we're going to search Google for Proffieboard. Enter. 2 men enter, 1 man leave. So this saber is going to get a Proffieboard V2, so I'm going to go to this website that I got on Google. So now we're on the Proffieboard V2 page on the Proffieboard V2 website. So if you scroll down, and for those of y'all that haven't watched any videos about Proffie, and I know most of you guys understand this, but for those that don't, when you go to this Proffieboard web page, and this is for Proffieboard V2, there's also another page for V1. There's another page in the works for Proffie 3.7, but we're not going to bother with that tonight. What we're going to do is we're going to begin making our configuration file, which is down here in this box. But we have to say what we have on our saber. So let's say I've got a main blade, Neopixel, let's say it's dual, and the dual is going to represent the stock crystal chamber, and, or the stock accents on my, and then let's say we have a Neopixel crystal chamber too, because that's kind of what we have. Now, this is going to be our main blade that's on FETs 2 and 3. Never mind the negative wire here, because it's not going to go to 4 and 5. This is going to be our stock connector, this second blade, but it is going to use data 2. And then our crystal chamber, we're going to have it running on data 3, I think it is. Let's see here. Let's look at the wiring diagram. Data 4. That's putting us on data 4. I don't know why I did that, but whatever. But our main blade here is on data 1. Now, this resistor, and Cole asked about this last week, this is actually in the stock connector, and I'll show you that here in a second. And this resistor, I didn't add one. Now, you can run these unresisted, but I'm probably going to zap a 470 ohm resistor in our line for our, this would be our crystal chamber accent pixel that we cut out. So I'm probably going to add a 470 ohm resistor into that line because there's not one. But the stock connector and the main blade won't need it. So once we do all that, we have our basic configuration file. And the important thing on the config file is, and I got 2 momentary buttons, no Bluetooth, none of that crap. And I do have a recharge port. So let me show you what we did tonight. So here's our positive Neopixel line coming out of our main blade, positive recharge port, positive battery, positive from our Neopixel accents, and they all merge. And then our pigtail is this wire that goes to the Proffieboard. Now, you could do this a gazillion ways to Sunday. The way I do it is I merge wires on one side, merge wires on the other side, and then put them together, but I add a pigtail that's going to run up to the board. And that way I just have one single wire that runs positive into the Proffieboard. In a circuit, the power runs from negative and then through all the components, and then it comes back through the positive line back into the board. So that's the flow of electricity. It goes positive through the load, negative through the load, and then back through the positive, back into the Proffieboard. So this positive line isn't carrying a significant of an electrical load as the negative line coming from your battery. The negative line coming from the cutoff leg on the recharge port is carrying a significant load. And you see our ground wire, common ground to both switches. When I say common, I mean the wires are going to the same place. Now you can combine these wires wherever, and if y'all remember from video number 2 of this series, instead of me wiring 2 wires off our switch legs, I just twisted the switch legs together, soldered them together, and ran 1 wire off. So that was my common ground. It didn't matter if you join them outside or on the switches, it just doesn't matter. But then your switch wires, go here and here. This is your main switch on Proffie 2.2, and this is your aux switch, but if you reverse them, we can switch it in the config. But the cool part is now we have a basic config file. And I'm going to have to make some changes to this, which are important for you guys to see my changes. Hello. So there's my config file. Now I'm going to copy that, and I'm going to open a notepad document, and then I'm going to paste this bad boy. And then I'm going to reformat all this, you guys know, because this drives me crazy. But off we go. I'm going to reformat that and adjust the line spacing to 1 and take out the 10 spaces and bada bing. Now, I have some shared power pins, and I need to go number sign, define, shared, I believe it's underscore power pins. And I don't remember if it's underscore power pins or what. Let me go look at, what was the last config that I did? Oh, you know what? My beta, my Proffie beta Saber. If I go to my config files, beta 3, this one has shared power pins. Shared underscore power underscore pins. So, shared underscore power underscore pins. And when I say shared power pins, let me go back to the website and I'm going to show you. So if you'll remember on the wiring diagram, I told you it's not entirely accurate because this is representing my stock connector, which is 16 neopixels. And the negative is not going to FETs 4 and 5 like you see it in the diagram, because the negative is shared on the main blade feed. So it's using FETs 2 and 3 for these accent pixels. So it shares power pins with the main blade. So that's why I had to do to define shared power pins. But now I also have to go down here into our blade defines, and I'll show you. So they have 4 and 5 here on this second blade, which is 144 pixels. So, number one, this is my first blade. This is my main blade. It's Neopixels, 144 pixels in the blade. This is where you adjust your blade length. You don't want to adjust your blade length up here. Leave this at 144. There's some rare circumstances where you don't want it there, but this is the one you adjust your blade length with, down at the bottom of the config. Most of my blades are around 130, so I'm going to leave it there. So our main blade is Neopixel, 130 pixels. It's on blade pin, which this is data 1. And there's the color order GRB, which they should be GRB. And then blade power pins 2 and 3. That means it hooks onto LED 2 and 3 on the wiring diagram, like we showed you earlier. Let's go back and look at the wiring diagram. So you can see this is our main blade, and the negative hooks onto LED 2 and 3, which you can see right here. I know those are 2 and 3, but if you're ever confused, you can come up here. You can see this is LED 2 and this is LED 3. So LED 2 and 3 are powering our main blade, but they're also powering our stock connector with 16 pixels. So now we're going to go back to our config file, and we're going to change this 144 to 16 because that's how many pixels are on that. We are going to use data 2. Color is GRB. Power pins are going to be 2 and 3, which are the same as our main blade, and that's why we had to define shared power pins. Now I can use power pin 4 for this blade, which is going to be our Neopixel accent, and it's only one LED. And let's say I want it on data 3 because I don't want it on data 4. I can just change it to blade 3 pin, which is data 3. And then bada bing. Now I have my basic config for this Saber ready to go. So what I'll do in the interim, because I want to get back to chat with you guys, is I'll go and swap out these blade styles. And for the new viewers that are watching, because we're writing a config file for our Saber, there is a preset. So preset starts in this bracket, and then what's in quotes is the font name on the SD card that it looks for, Teen CSF in this instance, and then comma, and then you have a tracks folder, and within that tracks folder there's a wave called Venus Wave if you have the default sound fonts, and then you have your 3 blade styles. The first one is for your main blade, the second one is for the stock pixels in the connector, and the third one is for our crystal chamber. And then this little bit in quotes is what would display in an OLED if you had one, and then that ends your first preset. And then this would be the second preset. and this would be the third preset. So what I'm going to do in this week is I'm actually going to put, modern, real FET263 blade styles in here in this section, and the fonts that I'm going to use on Tony's Saber. So that's kind of my plans for that. So this is a stock connector, and this is what's in the head of this lightsaber. And I don't know if you guys can see, but there are 16 neopixels that radiate out between the pins that actually make contact with the blade. And let me show you what the pins are, because I know some people don't know. This center pin is your neopixel data. This first ring outside of the data pin is your negatives, and they're all common to each other. And then the outside pins are your positives. So you can see you have more 1, 2, 3, 4, 5 negatives and 1, 2, 3, 4 positives. Because remember, we were talking earlier how electricity flows. It goes to the blade from the negatives, but returns through the positives. So there won't be as many amps needing to return through the positive, because a lot of it was scrubbed off, as it were, by the blade when it powered up the blade. So there's not as much power returning as there was, because some of it got, turned into light, something like that. So let's flip this puppy over. So the resistors you saw in my accent pixels on the stock connector, it's already on board. So you can see this. That's 331 ohms, 331 ohms. We actually removed this one because the connector was in V4. And I think I showed us wiring this one, and I don't know if that was in video 1 or what. I think it was. But at any rate, we removed this resistor because I wired it in V4, and then my second data line for the stock pixels, which is the brown wire, was attached here. My main data wire, which was purple, was attached to the center pin, and then I had one single 22 gauge black coming off this negative pin, and one single 22 gauge red coming off this pin. So I had four wires, 1, 2, 3, 4 wires coming off of this connector, and I don't need the resistor you saw in the diagram because it's already on board the connector. Now, I'm not running my main data through a resistor either, but all the blades that I built, I actually put my I put an SMD resistor in my blades. So I'll build a blade for Tony for this. In fact, I've already built Tony's blade for this saber. And, he doesn't need a resistor because the resistor is on board the blade. But this is the stock NeoPixel connector, the same one that's inside the saber we've been working on. So let's go back to the diagram. Let's go back to Windows Share. And let's go back to the diagram. So this is the resistor we're talking about, because remember we said this string of pixels represents pixels, so there's actually 16 pixels here. And it shows, hey, that needs a resistor on it. Well, it does. Remember, that one's on board the stock connector. Now, the one place we do need a resistor is here, which I'm going to show you that here in a second. So let me get this back in frame, and let's get you all back on this camera. Bam. Okay, so this series of wires here, this red, orange, and the black here that are twisted together, the orange is our data wire for this accent pixel, which is going to be, this is what's going to be lighting up the crystal chamber. So I do need to put a 470 ohm resistor in line on this orange line, and that's what I'm going to do. I'll add a resistor here. Maybe I'll show doing that next week, but the actual I'll have the NeoPixel already affixed inside the saber, but maybe we'll save that for next week, adding the 470 ohm resistor, because I hadn't planned on doing that tonight. But that is what we have when we get back to our diagram. Is this is, I'm sorry, that resistor is on the stock connector, but this resistor, which is the data line resistor for our accent pixel that's lighting the crystal chamber, it does need a resistor. Now, a lot of people ask, because on Proffieboard 2.2, the data line, data 1, is pre-resistored. It has an onboard resistor already right here, 330 ohm. And a lot of people ask, well, what if my blade has a resistor in it too? It's okay. We can actually combine, resistors on the data line. I mean, Frederick's tested it up to like 2,000 ohms and the data lines still work fine. So if you have a 500 ohm resistor and a 500 ohm resistor, you know, your data is still going to make it through. So what I have here is the Proffieboard 2.2, and I'm going to remove the SD card from said Proffieboard because we're going to be soldering on this thing tonight. And this is the board that's going in the Saber. I've already programmed this with a config, and you know, we'll have to go to the computer here in a minute to check the config on a few things because I don't remember everything that I did. But you know, we're going to be putting the main blade and the stock adapters on 2 and 3. I think we put my crystal chamber pixel on 6. And let's go see what we got. So we're going to make this happen on this Proffieboard. So we're getting ready to go off to the races here. I need to get a resistor out. I didn't do that before the show. So what do we got here? There you go. That looks like a good resistor right there. Okay, so we got Max, we got Melissa, and that's pretty much it. So we don't have many viewers tonight. This is a custom Gary Morris Hilt, Melissa, and I will show it probably at the end of the video when we get all this going. This is the inside of the hilt right here, and point out some things that I did for everybody. So I did add this, you know, multi-board adaptive chassis system in there and this piece of plastic across. I did that. I also added the battery cover back on. And, you know, everything's ready to go. Everything's ready to wire. And we just need to start wiring this puppy. I guess the first thing I need to do is start getting the wires that we need out and up through my chassis hole. So I'm going to remove all this tape we had holding the wires in. And, you know, I know right off the bat I'm going to need, I'm pretty sure we put this one on data 2, which is our stock pixel wire. And this is our brown wire from the stock pixels that controls the onboard data on those. And then I know I'm going to need, these are our switch wires. I know I'm going to need them, but we definitely need to pull our battery negative out of there so we can get it up through the hole where the Proffieboard's going. And then I need to go ahead and free all of this on the back. So on the back side, I'll stand by once I get this tape off. Of course, my pixel just came out right. That sucks. Well, that really sucks that my pixel came out. Might have to do some emergency engineering. Y'all stand by. That kind of is not good. Hopefully we'll get to installing here in a minute. Y'all just bear with me. I've got to do some emergency surgery that was unanticipated here to remove a wire. Alright. There is that. Now let me get that tightened back down. And then I'm probably going to have to do some emergency pixel surgery on that. So let me get out what I need there. Y'all stand by. We'll get this fixed. It'll be no problem. So while I'm waiting on all this, hey Kim Kanama, while I'm waiting on that to get fixed, let's go ahead and prep this Proffieboard because I can do that while I'm waiting to do all this other stuff. So as y'all know, and I'm going to zoom in so you guys can see this, but I bridge FETs 2 and 3 because I run a single wire to FETs 2 and 3. This is FET 2, this is FET 3. Those control my negative power to my main blade, and it requires the use of 2 FETs. So I'm going to go ahead and bridge those, which you'll see here in just a second. And I'm going to zoom in so y'all can see it. So let me try to zoom it on in. I'm going to try to make it big enough so Melissa can see it. I'm going to zoom it on in even further. I think that's as far as I can go. But at any rate, we're getting ready to solder this pad right here. And let me get my iron out and clean my iron up. And then we'll have to re-butter my iron. And we'll get to rocking and rolling here. I am using rosin core. It has flux in the actual solder, and I use, I don't know, it's around 60-40. This is resin core, and I'm using 6337, and it's 0.56 millimeter in diameter, so it's pretty small stuff, but it does have a resin core in it. So basically what I'm going to do is I'm going to heat the pad and the resistor, and then I'm going to come in with the solder. And just like that, we're good to go. So that is that. Now I'm going to cut the resistor. Let me get the board in here where you guys can see what I'm doing. I'm going to come in and cut the resistor, I don't know, about right there. And then I'll put that off to the side because I might be able to use that in some other project. Now I'm going to take this resistor that we've soldered there, and I'm going to route it into the LED number 2 hole, which I know this is kind of crazy with my shaky hands, but y'all just bear with me. And I'm going to pull that on up through there, and then you can see on the back side that I'm going to have that bridge, and I'll clean that bridge up and add some solder to that bridge too here in a bit. That'll give us some additional, but let's go ahead and solder LED 3 up now and complete this bridge of LEDs 2 and 3. Oh man, she really don't want to take solder. Trying to get my heat down a little bit lower on the pad. There we go. So now that completed that solder, and you guys can see I got a bunch of wires sticking up, so I'm going to go ahead and trim the excess off of there, and trim the excess off of there, and might need to clean that up a bit. I need to look at that under scope. I'll look at that under scope, but I think it's going to be okay. So now I'm going to come in on the back side, and I'm going to add some solder on the back side of this bridge. There. And then I'm going to add some solder there. And then more solder on the bridge. So there are LEDs 2 and 3 are bridged. So that's the prep work on the Proffieboard. Let me look at that. I don't see anything there. I think we're okay. I think we're okay. There is a little hair in there. That's not a hair of wire, it's just a hair. Alright. Sweetness, we're in business. Yeah, Proffie is probably the most complicated board that's out there, Melissa. Sorry I'm not reading the chat on time. My speaker wires. I got all this crap in there now. Get that out of there. Speaker wires. I had them all twisted together nice and pretty. I got to get them into the chassis because we're going to need them. Those would be like the second and third wires we wire, so I got to get them into the soundboard slot. So there they are. And next I'm going to need our switch ground in there and our positive in there. I'm just trying to get all my wires in there where we need them. Trying to this is like where it's doing surgery, where I'm reaching into the saber and pulling out guts. And then our positive wire, remember this is our pigtail from our positive merge that we did last week before we started some work on the config. And I'm going to go ahead and pull it up in there. And then I'm going to get my data and negative from, you know what, I'm probably going to leave the data and the negative from that Neopixel out. Let's go to screen share really quick. And let's look at my config really quick. And here's my config. So let me just see where we're hooking stuff up. So we know my main blade going to LED pins 2 and 3 uses data 1. My stock are going to data 2. And my crystal chambers going to data 3. And looks like it's going to power pin 4. So I went to power pin 4 on data 1. So now that I know that, I'm going to keep that handy, and I'm going to go ahead and pull out the old Proffie manual and wiring guide. Let's go to the internet, let's go to the webs. We'll go to Google, and if you guys ever can't find the stuff, I mean, I have all this on my web page, but I mean on my computer. But I'm just going to pull this up so we have it handy. So we are wiring a Proffieboard. No, this is actually a 1.5. I need 2.2. I had my brain on something else. We need Proffieboard 2.2. That's what we're wiring here tonight, and I'm bringing this out. So what we just did is we already soldered our jumper between LEDs 2 and 3 for our main blade, because I only use one negative 22 gauge wire on the main blade. LED 4 is going to be where our chamber pixel gets its negative from, and then LEDs 5 and 6 are blank, and LED 1 is blank, so we're not even using those. So I usually start wiring my boards down here. So if you can see, the first wire we come to is data 2. And data 2, if we look at my config file, is going to be our stock connector, data 2. So data 2 is going to get the brown wire from our stock connector. And then we come up here, and we don't have anything until we get to speakers. So we're going to wire data 2, and then our speakers. And then there's nothing on LED 6, but then we'll wire our aux onto this one. Our yellow wire goes onto this one. Nothing on LED 5. Then our crystal chamber negative wire on LED 4. Our main blade negative wire on LEDs 2 and 3, the junk we just did. Then our green wire, which is going to button 1. And then our black wire that feeds our crystal chamber goes on, oh no, it doesn't, it goes on LED 4, so LED 1 is blank. But then our white wire battery negative feed off the recharge port's going to this one. Our common switch ground's going to this one. Our main positive, which is our pigtail, is going to this one, battery positive. And then we come down here, and let's see what we have to wire on this side. Where is data 3? I know we're going to use data 1. Oh, so we are going to wire something here on data 3, which that's going to be our crystal chamber data, which is orange. So it looks like we're going to go brown, orange, blue, blue, and then yellow. So that's where we're at. So let me bring y'all back into the scene. And y'all stand by. And because I'm going to have to revert back to this in a second here. We'll get y'all back onto what we're working with here. So remember, I said the data 2 on this one. So actually it goes like this. Data 2, which is going to be here. is going to get the brown wire. Let me go back, and I'm not watching the chat. Yeah, so data 2 is going to go here to the second pin, so that's going to be the first wire we wire. So I always give a little bit of a slack, but you can see my data 2 wire goes into the stock connector there, and I'm going to give it a little bit of slack, but I don't want a whole lot of slack because I don't want to have to do massive cram foo down here. So I'm going to cut the wire about right there, which is near where the Proffieboard is going to be resting. I'll get into the flow here in a minute. Started off tonight kind of crazy because I was mad about that battery, and I'm like, wow, why are you running an e-cig battery in the Saber I built you? That kind of pissed me off. And then you wonder why it doesn't work. It's a vaping battery. That's why it didn't work. Which isn't what I recommended. I even sent him the Illume website. It blew me off. When you put cheap batteries in lightsabers, you get cheap results. I don't know what to tell you. Except for, I advised him not to do it, and he did it anyway. It's kind of like, screw you, build my Saber and I'll decide what I do with it. Well, that's fine, but don't come crying to me when you break it. You know what I mean? That's kind of not very good. And I try to give, you know, people the benefit of the doubt, but when you bring your Saber to me for repair and I crack it open and, you know, you got a vaping battery in it, what do you expect me to think? So I'm going to do the birch trick there where I fold it over, and let me go back to Streamlabs here. Oh, Melissa. Yeah, Melissa, I mean, this is really designed, this video tonight is really designed more for people that are learning how to install Sabers. I don't know how accessible, and I know you use that quote a lot, how accessible these sites really are. But it's the main site for Proffieboard. I don't know, you know, I know that everything's text on there and you can read it. So there is our stock pixels. Now next is going to be data 3, which data 3 is going to be our crystal chamber. It's this wire that's coming from our crystal chamber. So I'm going to have to get it routed in there. And I'm going to have to grab it with my tweezers. And data 3, let me go to screen share. And let's go back to the site. So data 3, speaker, and then skip 1, and then it's data 3. So data 3 is right below our speaker. So that's button 3, which we're going to skip that. But right below button 3 is data 3, which we need data 3 because our hang on a minute, let's pull up my config. You can see that my crystal chamber, the single pixel, is hooked to data 3 right there in my config. So that's what we're doing. So let's go back to the scene and get back on there. Alright, so I'm going to put my Proffieboard about where it belongs. And then I know that, I'll get y'all zoomed in again here in a second. I know this is a speaker and this is a speaker. So this is the one we're skipping. So this data wire is going to go right below the 2.2 there. Speaker, skip 1, bam, data 2. I'm going to leave a little bit of slack, but not much, because I don't want, you know, a ton of cram foo underneath the lightsaber. And once I get this stripping up in there, I'll zoom it in. I don't think I zoomed it in for the last solder, so I'll zoom y'all in for this one. I'm going to strip a little bit off of that, and then I get it away from the board before I tin it, because I don't want to be dripping, you know, solder inadvertently onto the board. And I'm going to put a little bit of flexures on there and bring my iron in, and we'll tin this wire. When you tin the wire, it keeps the wire together in one piece. You know, these stranded wires, they kind of like to fall apart. So I twist them and I tin them. And that makes everything a lot easier. And then I'm going to hold on to it with my hemostats, and I'm going to put it up through the hole. Now you can see, hang on a minute, let me show you all this, because this will be interesting, and I'll have to move this around where y'all can see it. So if you notice, you know, where I had my hemostats, I actually have some insulation sticking up through the hole, and that's not good. So stand by, let me re-grab that wire a little bit lower so insulation's not coming up through the hole, and then I'm going to bend that wire over, and now we're good. So we're working right here on this pad, right there, right below the 2.2. This is data 3. This is our crystal chamber Neopixel data. That's where that single pixel that we wired gets its data from. And bada bing, we're good there. And I'm going to cut off our Jeff Birch method piece of wire. And now we're getting to our speakers. And I know the speakers are next. And I know this blue wire is our speaker wire. And I know I'm going to need about yay long on the speaker wire. And let me zoom y'all back out so I'm not killing you, so you guys can kind of see what I'm having to do here. Alright, so I'm going to get one speaker wire out, and I'm going to strip a little bit off of it, just a little bit, just like that. I'm going to twist it away from the board, and I'm going to dip it in a little bit of flux. And I'm going to tin this wire. Bada bing. Now I'm going to grab it right below where it's stripped with my hemostats, because I don't want that insulation going up into the board. And then I'm going to pull out this other speaker wire, and you can see it's like pulling out intestines and arteries. And I'm going to strip a little bit off of it, twist it, add a little bit of flux to that, and we'll tin it, and then we'll come grab that in a second. I'm just going to go ahead and tin both the speaker wires while we're at it. Okay. So both our speaker wires are tinned, and now we're going to put one up through the first speaker hole, and I'm going to bend it over, Jeff Birch method. And I'm going to clean off my soldering iron because we're coming to the board, and put a little bit of solder on my tip. And you know what, we'll zoom y'all in so you can see me coming in for the kill here. You can see my shaky hands. Shaky hands. Bada bing. Cut off the little bit that we bent over. And then let's go grab the other wire that we already tinned. And I'm going to grab it right below where we stripped it. It's coming up through the speaker hole. And we're going to bend it over, Jeff Birch method. Just like that. And we're going to come in for the kill on this one. Bada bing. So we're doing pretty good. Hey Cole Weathers, glad to see you here tonight. Now, the next wire I'm going to need is LED 4, which is going to be, let me zoom y'all out. So I know you guys can't see really good, but let me get something to point with. So this red wire here, this small red 30 gauge wire, and this black 30 gauge wire, and this orange 30 gauge wire are all coming from our crystal chamber Neopixel that we wired last week. So basically, I need to bring in this black wire next. So this black wire is going to feed our Neopixel that's in under the crystal chamber, and I'm going to have to thread it through here very carefully and grab it. This is where hemostats come in handy, because you can imagine trying to reach in there with your big gloppy hands like I got, and it's hard to grab those wires. and I'm going to bring it up, and it's going to go to LED 4, which is right there. And I'm going to confirm that on my config. So stand by one. Let's go to screen share. And let's go to my config again. And it looks like our crystal chamber LED, which it's 1 pixel on data 3 that we just soldered. And indeed, it does go to power pin 4. And so then we can go to Frederick's page, and you can see that LED 4 is right here. And that's where we're going to be soldering this black wire we just brought up. Ooh, and I need to do my button 2 before we do that. So let's go back to button 2, which is going to be my yellow wire. So we'll do my yellow wire, and then we'll do this black wire. So stand by, we'll get back to that. Oh yeah, I do use shared power pins, Kim, on my stock connector. I'll show you. I am using shared power pins on this Saber, but for my crystal chamber, I'm just using, this one's not really using up a lot of blades, Kim, so I'm able to get away with, you know, not totally using up all my LED pins. In fact, even when everything's wired, I still have 2 unused MOSFETs on this build. LEDs, well actually I have 3. I have LED 5, 6, and 1 that aren't used. So this is my yellow wire. This is my auxiliary switch wire from the second video in this series. I know the lightsaber is going to go about right there. So I know that wire needs to be about right there when I cut it. And you can see, you know, I've got quite a bit of scrap. So let me grab this wire now with my needle nose, and we'll strip it. And the further we get along, the less wire insanity we're dealing with. So it's kind of insane right now, because we're at the point where we're starting to work our way around the soundboard, and you know, it's a bit insane. And to give that a little twist, a little tin, some solder. So this one is using shared power pins. I'll show you that in the config here in a second. So my stock connector is actually using shared power pins. So this is my auxiliary switch. I always make my auxiliary switch yellow, and my main switch is green, which the green wire you see over there is indeed my main switch. And we're going to put our auxiliary wire up through the hole there, and I'm going to zoom in here so you guys can watch it happen. So right now we're going to be soldering this right here. That's our auxiliary wire coming up through there. Here come the shaky hands. Let me clean off my soldering iron, put a little bit of fresh solder on my iron, come in for the kill. Bada bing, that's it. You don't want to stay on these pads too long. You know, you can really mess things up. Alright, so now we need to get to LED 4. And this is the black wire from our single Neopixel that's feeding the chamber. And I know it needs to be about yay long. That's going to leave some slack in it. Oh, of course, then it tucked back in there, didn't it? I'll be glad when we get the positive and negative wires out of the way, because they are killing me. And I need to get y'all zoomed back out, so not that. Let's zoom you back out. Zoom you back out. So I'm going to strip this wire. And then I'm going to have to turn this Saber around, because I don't like reaching over the soundboard with my soldering iron. So when I get to this point, typically after I round the bend, then I'll turn the Saber around so that the soundboard is closest to me, so I'm not having to reach over the soundboard with my soldering iron. So now I'm going to grab onto this, and actually I think I'm wanting to reroute that, because I want that to go right here in LED 4. And I'll zoom in on that here in a second and point it out. This is our Neopixel negative for the chamber on LED 4. I'm going to zoom you all back in as we come in for the kill on this one. LED 4. And by the way, I do have the kill key in this Saber, so it does not have power right now, hopefully. Might have been a good idea to check that before we did this, but you know. it is what it is. Okay, so now I think what I'm going to do is I'm going to turn this saber around. I'm going to get some of these tools out of our way. I'll get y'all back in frame here in a second because we're getting ready to start getting into some business here. So I know I need to get my main Neopixel data, which is this purple wire. I need to go ahead and get that into the chassis. So I'm going to get that on into the chassis where it needs to go. And this is my negative wire, which is already in the chassis. That's my battery negative, and I don't like where that's at because it got wrapped up. So we'll pull it out because it's going to be over here. And then I know I'm going to need this, stand by. I know I'm going to need this green wire. This is my main switch, because after we get the main pixel negative mounted on, which we haven't routed that wire yet, we're definitely going to need this green wire in the chassis. So let me grab that green wire and get it in the chassis. Let me see if I can route that better. It's all twisted around something in there. Stand by one. Because I want the routing to not look horrible. I mean, you know, the Saber owner is probably never going to see this, but the bottom line is that I don't want that routing to look like that. That's not where I wanted it. So I'm probably going to have to strip this wire, or not strip it, but I'm going to have to cut off the end I had stripped, because it was kind of like not allowing me to go where I wanted to go with it. And I need to go under that. There we go. I bet this is going to work out just fine. Yeah, that's where I wanted it. And then the next wire I'm going to need, let me get this back up here where you guys can see. This is my main Neopixel negative. This big thick black wire. This is for my main blade. And I know I need to get it into the chassis where we're going to be wiring. So I'm going to pull it on through. With my hemostats. And bada bing. So that's the next wire to get soldered. And let me get these other wires out of the way. And we don't have many wires left here. But now I'm going to solder our main Neopixel negative, which it's going to go on our FETs that I put a jumper in. I'm going to give it a little bit of slack to it, probably more than I need. And I'm going to go ahead and strip about the amount of wire off that'll cover our jumper. And I can clip this. Stand by. I got y'all zoomed in too far. I can probably clip this a little bit. I'm trying to get it where you guys can see it. Get a little bit of fluxure there. This is going to be hard because we're doing this on the underside of the board. And this is the one that y'all kind of can't see because the camera's above and I really need the camera below to see this. But there, I pre-tinned the wire. Now, what I typically do is I'm going to grab onto this with my hemostats. And usually what I do is give it a bend like that so it matches where I need it to roll. And I don't know if you guys are going to be able to see this or not. Probably not. And actually, you know what? I'm going to try to get this in a position where you guys can see what I'm doing here. But I'm going across those two pads with solder. This is my main Neopixel negative. And let me get some solder on my iron. We've already pre-tinned this wire. We've already pre-tinned the pads. Now I want to get to line up like I want it, where it's hitting both pads. I don't know that I like that. Yeah, that wire is a little bit long, so I'm going to cut some off of it, so stand by. Let me desolder that. I'm going to cut some off of it. And I don't like how long that is, so what I'm going to do is I'm going to cut, I don't know, 1 millimeter off of it. And we're going to come back in here and we're going to try this again, because I don't want this wire touching nothing else. And there's going to be quite a few amps rolling through this wire. Get some solder on my iron here. Now I am happy with that. Oops, dang it. You guys didn't even see it. There it is right there. But it's on the underside. Try to get it where you can see it. This is our main Neopixel negative right there we just soldered. Okay. That's the hardest solder of the whole install. Now, we're going to be rocking and rolling. So the soundboard's going to go about right there. Now we need this green wire, which is our main switch. We're going to cut it about yay long. Then we're going to grab that wire with our needle nose pliers. I'm going to strip this. This is 30. I use 30 on switches and single neopixels. And this is 30. Trying to get y'all back in frame there. I'm sorry. Sometimes I'm paying more attention to what I'm doing than try to keep it in frame, but I'll try and keep these last several wires in frame so you guys can see it, and I'll try and zoom in on this solder. It's hard for me to zoom in on that other one, on the Neopixel negative. Ugh. What just happened there? Alright, so there's the wire, and I'm going to bend it over, and then I'm going to zoom y'all in, and I'll move the Saber in, hopefully so y'all can see where we're at. I'll point it out with the solder here in a second. Hey, Bobby Susanbach. Yeah, I mean, the hemostats really come in handy here. So this is the pad we're on. This is our main switch pad. This is our green wire. Oops, that needs to be cleaned off. And we'll put some fresh solder on there. It's good to keep your iron with fresh solder and clean. Kind of helps the solder to do that. And then come in with our nippers and clip off the excess there. And hit that again. Looks like it needs a little bit more solder in there, zoomed in. I want it round. I want it nice and round. Like that. Doesn't that look better? Bada bing. Alright, so next is our main battery negative. That's this big 22 gauge wire. Let me zoom out so you guys can see what's going on here. So our main battery negative, I know, goes to this line right here, and this is our main battery negative, which is this big beefy 22 gauge that's coming out of a recharge port. And I know it's going to go about right there. I'm going to leave just a hair of slack. I'm going to go ahead and cut the excess that I don't need off. I'm going to come in here and I'm going to strip it. Now I won't be able to fully assemble the Saber tonight, y'all, because I've got to glue the Proffieboard down, and I'm not going to do that with hot glue. I'm doing it with E6000, just like I glued the plastic chassis in there. And you know, that E6000 I'll have to set up for 24 hours before I can button the Saber up, but trust me, I will show the completed Saber hopefully next week, next Monday. Alright, So now our main power, our main negative wire is in there, and I'm going to try to keep it in frame for you guys. Again, I'll show you with the solder where we're going. We're going right here. This is our main negative. This is the coming off the kill side of our recharge port, and we're going to rock and roll here. I'm putting heat on the pad and then adding the solder to the tip, and it flows onto the pad. That's all I'm doing there. Okay, so the next wire we're going to need is our common ground on the switches. So let me get the hemostats off here, zoom back out so you guys can see what I'm doing. This is our main common negative for both switches, and it's going to go, you know, when our Proffieboard's installed, it's going to go about right there. I'm leaving a little bit of slack on it, so I'm going to cut it just above the board. Then I'm going to strip the wire off of this. This is 30 gauge. This is my common ground for both switches. If y'all remember from week 2 when we wired the switches, we wired 2 of the legs together, and this is the white wire that feeds both of those switches. Now, I'm going to grab it with the hemostats, and as Kim Kanama said, hemostats are invaluable when you're doing this stuff, holding your wires for you, especially like now when I'm filming. I mean, I do have helping hands, but these hemostats become, in effect, my helping hands when I'm having to film and I can't get my helping hands in here because of the tripod, because I'm filming, you know. You know, I think we've been doing so much building on Megtooth Mondays. I think one of these Mondays I'm going to have to take a break and we'll just do a Saber talk. You know, I wanted these things to be productive, but at the same time, it's stressful, you know. Everybody's watching me mess up here. You know, we'll see. Now, next is my main positive, and I don't like how that main positive is routed. Let me try and do something here to make that better. Now this is our pigtail that we soldered on, and this is our main Neopixel data. And our main positive is going to come up right here, and it's 22 gauge, and I don't want to leave a whole lot of slack because it's hard to shove down in there. So I'm going to go ahead and cut it about there. And then let's go ahead and strip this. This is 26 gauge. I'm pretty sure I used 26 gauge on this one. I did. So everybody asks, well, you have 22 negative feeding the board. Why don't you have 22 positive feeding the board? Remember, in a DC circuit, electricity flows from negative to positive. And on the Proffieboard, the only positive is needed just to power the Proffieboard. Now, you get full amp flow of the negatives going through the Proffieboard, but a lot of those amps get scrubbed off by the blade when it's lit up. So you need very little positive to run the board. It just draws, you know, I think half an amp or something like that. It just doesn't draw much electricity. Now, this is one where you don't want any, you know, this is the precaution, because let me get y'all zoomed in and hopefully where y'all can see this. Let me get y'all zoomed in here. And let me get the Saber where y'all need it to be so I can point something out. So our battery positive, which we're getting ready to solder, is right here. This is ground. This is battery negative, which needs more solder. You don't want any bridges between ground and battery positive. This would be bad. So this is a major area where we don't want bridges. Now these pads are right next to each other, so you kind of got to be careful. Let's add some more solder to my battery negative, shall we? Yeah, I like that better. You don't like that better? Now we're going to add a little bit more solder to my tip after I cleaned it. And we're going to come in on the positive. Just like that. Now, let me trim that wire because there's quite a bit of wire sticking up there. And then I'll come back and reflow that a little bit. We'll see how we like it. I like it. Last wire, y'all. Moment of truth. Hero or zero? Who's placing bets? Who's placing bets? Am I a hero or a zero when we pull the kill key? Or do we have a mix? What's going to happen? What are their predictions? Hero or zero? This one needs to go to data 1. Shit, I can't remember which one's data 1. So, let's go back to Windows Share, no peek. And let's go look at the wiring diagram. Data 1 is the third one up, right here. Lord have mercy. COVID. Data 1's right there. So that's where we need to go. How do I get back to you guys? Oh. I'm running the stream here. Yeah, I don't know if I'm going to be a hero or a zero here, but we're fixing to find out. So data 1's the third one up, which this is our data for our main blade. So I know when the Proffie's installed, when I get the soundboard tucked in, she's going to be about right there. So I know this one needs to be cut about right there. Now I did use 26 for my main blade data. Ooh, and that piece of wire went down in there. I don't want that. Get out of there. And you don't need 26 for main blade data. I just like it because it's a stouter solder and it doesn't pull off the adapter easier. And sometimes what's happened is I get a Saber all wired up and, you know, I get to the data wires and I yank them out of the adapter, you know, getting impatient to finish. And so I typically like using 26 because the wire's a little bit stronger than 30. And but you don't need 26. I mean, you could use 32 for data. So I'm going to pre-tin this data wire. Let me pull y'all out. Dang it. Let me pull y'all out here. You guys couldn't see that. We were zoomed in on the Proffieboard. But now we're going to pre-tin this wire. And she's pre-tinned. Now I'm going to put this wire up through data 1, which is the third from the back, like we just looked at. And I'm going to Jeff Birch this thing. Just like that. And I'm going to turn this so y'all can hopefully see it. And let's zoom in for the last wire. And I gotta forget to put the, I can't forget to put the SD card in here to make sure that it works. Ooh, that's pretty. I like that. That'll work. Now let's cut that spare piece of wire off the side. Reflow this one a little bit. Make it pretty. Bada bam. Pretty as you please. I like that. Okay. So basically, the Proffie is wired up. Now it'll, let me zoom out so you guys can see where it's going to go. Let me zoom out and you can see where we're going to go. So the Proffieboard is going to rest right in there like that. So you can see there's not a whole lot of cram foo going on because I cut my wires all to length. So I should be able to fairly easily glue this Proffieboard in place right there. That's going to be your resting position. You see it wants to spring up. And it wants to spring up because of, you know, all the wires that are beneath it. But I don't have a whole lot of cram foo going on. But I'm going to put in the SD card. I hope this is the SD card for this Saber. And then we need to pull the kill key. So let's turn off the lights. Oh, let's see if we have some joy. Well, the crystal chamber works. Oh. Motion gestures work. Test the aux button. You can see the crystal chambers flashing like I programmed. I'll show you that here in a second. I'll talk about the fonts that are on it next week.
I suggest you try it again, Luke.
This is Kyberphonics New Hope training.
This time, let go your conscious self and act on instinct.
Let's see if multi-blast works. Alright, multi-blast works. Gesture off. Next preset. I put the seismic charge blade on there. Next preset.
Are you a Jedi?
K-Sith. From The Mandalorian. That's awesome.
Kylo Ren.
Now this is Congress.
Kylo Ren.
Ah, there's my pulsing fire blade. I need to put that on the other one too. Look at that pulsing fire blade in the crystal chamber.
Are you a Jedi? I am.
Rainbow blade. I think that's a rainbow fire blade. Yeah, there's the normal rainbow blade. And then my battery meter, which is also showing in the stock connector. Which, why is that only got 4 LEDs going? Oh, because it's on battery meter. Yeah, all 16 LEDs are going when it's not in battery meter. Because it only shows on the end of the blade. That's why. So anyway, bam! Hero! It works. Let's put the kill key back in it until I can glue this together maybe tonight and solidify this up. And celebrate good times. Come on. She works. So this is the, basically it's a saber within a saber. So I have to get the soundboard glued down, and then I will slide the top of this puppy on, and the bottom will go on, and I have them stored away somewhere safely. They're not anywhere close by. But what I'll do is next week, you know, I'll bring the saber out and we'll show it off. But you've been along for the ride on 4 Megtooth Mondays. The last 4 Megtooth Mondays have been dedicated to the install of this lightsaber. So I'll neaten up the wires in here and try to route them nice and neat. And we'll finish putting this puppy together, and we'll hopefully be able to show it next week. But it all works. It's all functional. The config all works. It's awesome. My config file, and let's explain some things. So you can see it's a lot more extensive than it was. So I've got the volume set at 2000. There's 3 blades, 2 buttons, 144 LEDs per strip. You know I'm going to have to put the front on the saber and test it to make sure a main blade works in tonight, but I don't have time to deal with all that because I'm going to have to take the board down. Clashes at 1.9, audio motion. Now, Kim Kanama was asking about shared power pins earlier, so you can see I have shared power pins, and I'll show you why here in a second. And then you can see all my battle mode stuff here, which I'm using SA2C's battle mode. This one doesn't have swing on because we're having some issues with swing on, but it does have twist on and thrust on and twist off. And then the lockup delay, I've got motion timeout, idle off time, so that crystal chamber will die, you know, after so many minutes, and it's also save state because everything's color changed. This section here is me adding in SA22C's buttons. They aren't on the OS download, his prop file, so you have to go get that off the Facebook groups, or Matt McGurry can email it to you. And then that first font was Orichi, and that is by Sith. And you can see the blade style for it here, and then the next blade style is for my stock connector. And then the last blade style is for my crystal chamber, which all it does is it pulses between white and black at 5,000 milliseconds. That's preset number 1. The second one is Energy Blade by Kyberphonics. You can see my 3 blades for that. And then A&H Training by Kyberphonics. And then Seismic by Brian Connor, with Brian Connor's like epically long, blade style, and both the main blade and the stock connector. And then my my third blade style on that one is right there, which is very simple. It's it just pulses between his main blade color and black at 3,500 milliseconds, and then it just uses a simple blade style for when it's on. Then I had K-Sys Rescue, which this is a green color changing blade on the main blade, green color changing blade on the stock connector, and a green color changing blade on the crystal chamber, but when it's off it pulses between green and black at 4,500 milliseconds. And then yada yada yada, we can go on and on and on with the rest of the presets on the Saber, but we get down to the end. Now at the beginning, you remember we said shared power pins. If you look, this is my main blade in the blade configs down at the bottom. So my main blade is hooked on to data 1, color order is GRB, and it runs on power pins 2 and 3. But because I'm using a stock connector right here with 16 neopixels, it's also running off blade power pins 2 and 3, so I have to add the shared power pins in the top of my config. And it runs on data 2. That was the wire we put on data 2, the brown wire at the very beginning. And then lastly, my single neopixel that we put in the chamber, here it is, and it runs on data 3, and it gets power from blade power pin 4. And you saw us solder that on tonight, and that's it. I'm going to go to the style editor, and I'll give you the address for this. And let me get rid of the blade that's in here, because we're going to put the blade I just grabbed from my config in here. This was the main blade on my, and you got to hit submit once you paste it in, submit. So this is my main blade that's on K-Sys Rescue. So it's just, a green blade, but it's color changing. There's your clash, stab, blast, lockup. You can see how your lockup's going to look. It's localized. But at any rate, so that's the main blade, right? Now I'm going to power it off. Now, if you come down here on the main base layer, there's a color went off. And we're going to try to find it. And I've done this in other videos, but might as well answer the color tonight since you asked. I'm looking for it. I'll find it because I found it already. Usually it's at the end, but Fernando's blade styles are so complicated with so many layers that sometimes it's hard for me to find it, but I will find it. Here we go. So right here at the bottom of the blade style, see where it says color went off? Well, it's black. Well, let's say I don't want it to be black. So we know this is a green blade. I want it to, and I'm going to go to Styles tab here, I want it to pulse, but I don't want it to pulse between blue and red. I want it to pulse between green and black. So between green and off, black is off. And let's say I don't want it to do this at 800 milliseconds. I want it to do it at 4,500 milliseconds. And then I'm going to submit that 4,500 milliseconds. And now let's watch. So now the Saber is off. But you can see even when it's off that it has this pulsing. So that's what I do. I just take a blade style and I give it off behavior. So you can see here, color went off. It's now pulsing between green and black at 4,500 seconds. You just have to find color went off on one of Fernando's blade styles. So hopefully that shared that. And, you guys kind of understand that. So, bam. Little quick tutorial, quick and dirty on the, and we did it. But, bada bing. It's not that hard to do. You just have to learn how to read the blade styles. And, I found it pretty quick right there. And you just have to find color went off. And instead of it being black, you want to add a style in there. Because everywhere you have a color in a style, you can add an effect. It's called layering, and there's a lot of layering in the blade effects on the Proffie OS. That's what makes Proffie such a powerful weapon with Neopixels, is basically your imagination is unlimited. Whatever you can desire to do in a Neopixel blade, Proffie can do it. Is show you all the sabers. So here's the finished saber. This is the saber that we've been installing for the last 4 Mondays. This isn't the final kill key. We'll go ahead and boot it.
He is strong with the Force, but talent without training is nothing.
Oops.
Kylo.
Let's get to the right preset.
Kylo Ren. Orochi.
Orochi. This is one Sis Orochi, and then I'll show you the crystal chamber. And I changed the link on my Facebook page too. So, yeah, I'm having some intermittent internet problems. So far, it looks like it's okay, but there's the crystal chamber on this thing. You know, it's kind of cool. You can see how clean it is. But there's the crystal chamber. It's doing that pulse that we programmed in, and I showed you all how to do that. And then, you know, the saber is pretty clean. You know, I mean, where's the Proffieboard? Nobody knows. It's a mystery. Gary Morris did a lot of great engineering on this hilt. The only thing that I don't like about the hilt is the only sound venting there is that little hole there in the end. I don't know if you guys can see it. That's it. That's the only sound venting on this, so it doesn't allow a lot of sound out, which kind of muffles the sound. So I'm going to have to see if I can turn the sound up a little bit. But there you can see the pixels going in the hilt. And of course it's got, you know, all gestures and everything. But anyway, I'll show you really quick the saber lighting up. And I don't have blade retention worked out on it yet, but there you go. Localized lockup. Lightning lockup. Blasters. Clashes.
I suggest you
Seismic charge blade. And then, of course, you know, it has gesture ignitions and gesture retractions. So, you know, it's a pretty cool saber. I think it turned out really good. And that is it. That's the Gary Morris Hilt that we've been installing on the last 4 Megtooth Mondays. I may try to take that video, you know, take the live streams and edit them down to like a install tutorial video. Thank you everybody for watching as usual. I really appreciate y'all tuning in on my channel. And as always,